Before moving on from the topic of objects to the topic of functions, I just want to very quickly compare primitives and objects. We actually talked about this very briefly at the beginning of this section, but then we were too busy talking about the prototype chain and those important things. But let's get back to it now. So let's get first rid of this code here. All right. So primitives versus objects. And we basically know that only numbers, strings, booleans, undefined, and null are primitives, and that everything else are objects. And we already know a lot of differences between the two, so let's now compare them even more. So a big difference between primitives and objects is that variables containing primitives actually hold that data inside of the variable itself. On objects, it's very different. Variables associated with objects do not actually contain the object, but instead they contain a reference to the place in memory where the object sits, so where the object is stored. So again, a variable declared as an object does not have a real copy of the object, it just points to that object. So let's see this in practice. And I'm going to start with primitives. So let's define a couple of variables. So let's simply call it a and set it to a random number. And then let's create variable b and say it should be equal to a. Okay? So b is now also 23, right? And now I'm going to mutate a, which means to change its value, and I'll change it to 46. And let's now simply console log a and b. A and b. So 46 and 23, that's what you expected, right? So a is 46 because we changed it from 23 to 46 here in this line, and b is 23 because up here we said that b should be equal to a, right? So what we did here was to simply copy the value of a to b. And when we then changed a to 46, this did not affect the value of variable b, which still is 23. And this means that each of the variables actually hold their own copy of the data. They do not reference anything. So two variables holding primitives are really two different things. So let's do something similar with objects this time. So obj1, so this is our first object named John, and then just set the age to 26, okay? And now something very similar, I just say object2 equals object1, okay? Such as we did before with b equals a. And now I'm going to mutate the age on object1. So .age, and I'm going to change it to 30. And then let's console log the age on object1 and duplicate this line and object2. All right. So we have a small bug here. All right. So because this should be object1, of course. Right. So what happens now? Okay, they are both 30. So object1.age and object2.age are both 30. And that's really strange, right? Well, not really actually. And that's because when we said object1 should be equal to object2, we did not actually create a new object. No copy was created here. All that we did was to create a new reference which points to the first object. So the object1 and object2 variables both hold a reference that point to the exact same object in the memory. And that's why when we change the age on object1, this change is also reflected on object2, because in fact it's the exact same object. So this is some really interesting stuff, right? It took me some time to actually understand this. Now with functions, it works in the exact same way. So let's see what happens when we pass a primitive and an object into a function. So let's create some space here. Objects, these were the primitives. And now functions. So I'll start by creating an age variable. Okay, and then another object. And this time it's not going to be John, this time it's me, so Jonas. And I will say the city, and that's Lisbon, so the city where I'm currently located. And now we write a simple function, which I'm just going to call change, and it receives two parameters, a and b. And all this does is to mutate the data. So we want a to be 30, and we want b dot city to be San Francisco, for example, because it's a really nice city, you know? So now we're going to call this function, and as you can guess, we are going to pass age as the a variable, so as the a argument, and the object as the b argument. Okay? And now, once again, we will simply console.log the result to the console. So the age, and then console.log obj.city. So what do you expect is going to happen now? And let's see. Okay, so 27 is age, and this object city, so the city attached to the object variable, is San Francisco. So we have the same thing here. We pass the age variable holding a primitive and the object variable holding a reference to an object into our function. This function then, as it was invoked, attempted to change the arguments that we passed into it. So when we then console log the values, we see the same thing as before. And that is that the primitive has remained unchanged, but the city in the object has changed from Lisbon to San Francisco with this line of code here, right? So this shows us that when we pass a primitive into the function, a simple copy is created. So we can change a as much as we want. It will never affect the variable on the outside because it is a primitive. But when we pass the object, it's not really the object that we pass, but the reference to the object. Okay? So again, we do not pass an object into a function, but only the reference that points to the object. So when we then change the object inside of the function, it is still reflected outside of the function. So I hope that this shows you that it's really something very important that we should really be careful about, right? Because this can lead to some unexpected results and some strange bugs. And that's why it's super important that we have this information now. Cool. So let's now go to the next lecture right now. Now that we have learned a lot of new stuff about objects, let's switch to another topic, functions. And actually, it's not a completely unrelated topic, because we already know that functions are also objects. And that being said, it makes sense that with functions, we can do the same things that we can do with objects. So let's see some facts about functions. First, as we already know, a function is an instance of the object type. And because of that, a function behaves like any other object. We can store functions in a variable, and we already know that. And we can pass a function as an argument to another function. And we can also return a function from a function. And because of all that, we say that in JavaScript, we have first-class functions. So let's see a real-world example of how functions can accept other functions as arguments. And actually, we already did this. Do you remember the pick game project that we coded before? We set up some event listeners back then, right? And we passed a function into each one of them in order to handle each event. So back then we already used first-class functions, but we didn't just know it. Alright, so let's now imagine that we have a couple of arrays filled with values and that we wanted to do some calculations with them. And a birth year array could be a good example of this. So let's write an array with some years in it. So 1990, 1965, 1937. I'm just going to write 5 numbers here, so 5 years. 2005 and 1998. Alright, so 5 years. So remember, we want to do some calculations with these values, or based on these values. Now, we could do a huge function which does all of these calculations that we want to perform at the same time, and then results all the result arrays at the same time. But that would not be really good practice, because instead, we can write a function that will receive an array and return a new result array and do the calculations based on a function that we pass into the calculation function. So let's write that calculation function and call it array calc. So function array calc, and what we're going to pass in here is the array, which will be, for example, the years array, and then we will pass a function which does the actual calculations. So let's see what this function does. So in here, we will simply loop over the array and return a result. So the first thing is to create a new empty array, which will be the one that we're going to fill and then return. So var r for the result. So I'm just going to say res here. And it's an empty array. Alright, and do you remember how we loop over arrays? So we've always been doing it using the for loop, right? So let's continue doing it this way. So we set up a new variable I, which is our counter, set it to 0, and then loop as long as I is smaller than the length of the array that we input, right? And by now you already know how this length property works, right? And then after each loop, we increment our counter by 1. Okay, and so down here, inside of the loop, we will then use the function that we can pass into this function. So we will push something into our result array here, right? So we can do it like this. We use the push function, or the push method, to be correct, which, as you remember, inserts an element at the end of an array. Okay, so the big question here is, what are we actually going to push into the array? And the answer is that it will be the result of calling our fn function. So fn, and then we pass the current element of our input array into this function. Array I. Okay? And this will make a lot more sense after you see one of the functions that we're going to program next. So I will explain it a little bit better by then. And now all we have to do is to actually return this result array. So return, of course, the res. So let's now quickly write one of the functions that we can then later use here as our fn function. So we will write a couple of simple functions that do only one single task. And these functions will actually be called callback functions because they are functions that we pass into functions that will then call them later. In this case, our callback function fn will be called here when we want to push a new element into our array. So let's now write one of these functions, and it will be our well-known calculate age function. So let's do it like this. Function calculate age. And this time I'm simply going to call it L, which stands for element, okay? And we're going to return 2016 minus the element. So this was usually called our year of birth parameter, right? but this time we're simply going to call it EL. So this is one of these simple functions. So you see it only has one task. It receives this L argument and then returns the H based on that argument. So really simple. And now our arrayCalc function can make a lot of more sense, right? So let's see what happens here. So again, we have our empty array here, and then we start looping through the array that we input, which is, for example, this array here with all of these birth years. So when we then hit this line in code here, what's going to happen is that our callback function fn will be called with the I element of the input array. So imagine in the first loop I is 0. So with this ri, we're going to retrieve the first value of the years array, so 1990, and then we'll push this 1990 into the fn function, which will be calculate age, right? Then this function does its work, and it returns 2016 minus 1990 in this case. And then the result will simply get pushed into the array. And after this is completed 5 times, then the result will be returned. So let's see this in practice and actually call the arrayCalc function. So arrayCalc with our years and calculate age as the callback function. So again, I'm not going to call the function right here, because this way I would need the parentheses like this, right? But that's not what we want. We don't want to call a function here. We want it to be called later by the arrayCalc function. And that's why it's called a callback function, because it's called later. So we simply pass this variable, which is this function, right into this other function. Okay, now we just have to store this into a variable, because other way we cannot really see it. So I'm going to call it ages, right? Then we just need to put the correct name here. And then let's console log this array. Ages. So let's see if this works. Okay, so we have a small bug here in line 109, you see? So line 109, and here I see the error. It's not a comma, it's a semicolon. Okay, let's try it again. And now we have our ages. So this actually worked. So our arrayCalc function looped through the years array 5 times, right? And 5 times the calculate age function here was called and then pushed the result right into the array that we then returned. So again, we can imagine this function as a generic machine that loops through an array, and we can tell that machine what to do with each element in the array. And that's what we do with our fn parameter, which is the callback. Okay, so let's now write another callback function so that you can really see how powerful this pattern can be. So let's now write a function which can determine if someone is of full age. Okay, so function is full age, and again we're going to receive an element simply here. So we just use a very generic parameter name here. So this time we're simply going to return if the element is greater or equal to 18, right? So we simply want to return a true or false value, and that's what this comparison operator here returns, right? So if the element is greater or equal to 18, it will be true, and otherwise it will be false. Okay, so let's test this one as well. Down here, and this one I'm going to call full ages. And then again we use our generic function, which I like to think of as a machine, and then we can use that as an input, the ages array that we calculated before, right? And then this time we pass the isFull function into our generic calculation function. And so now I want to log the full ages as well. Console.log full ages. Alright, so let's see this. And alright, this makes sense. So the only one here that's actually younger than 18 is this one. And so this one is the only one with false, right? So everything is working just fine. And as a third example, I have a really cool one which is the maximum heart rate. And that is the highest rate measured in beats per minute that a person can reach when exercising. And it's calculated based on the age of a person. So it's a great fit for this example here. And I thought this would be a really cool use case for people who like to work out. So let's see this formula and let's see how to use this. So function and max heart rate. And again, we're using simply an element as the input, and the formula is actually really simple. So return 206.9 minus 0.67 times the age. And the age will be the element. So we will always call our array calc function here with the age as the input, right? So not with the years, but with the age. Now we also want this to be an integer. So we want to return a value here that's not a decimal. So let's do that. And I'm sure that you remember the math object. And we used the ceiling method before, or the floor method, I don't remember. But now we're going to use the round. And what round does is very simple. It simply rounds the number to the closest integer. So very simple. Now only one thing left in this function here is that this formula is actually only valid for people between 18 and 81 ages. So you already know how to do that, right? So we use an if-else statement. So if the element is greater or equal to 18 and at the same time less than or even equal or less than 81. And that's it. So in this case, we want to return this. And if the person is out of these ranges, then we simply return -1. Okay, and that's it. So that's our function for the max heart rate. And once again, let's now use this. So let's just call this rates and then array calc. And again, we're using the ages as an input. And then our callback function is the max heart rate. And now instead of the full ages, I want to log the rates. Okay, so here are the calculated heart rates, maximum heart rates, which is only -1 for this person here. And that's because it's clearly younger than 18. All right, let's think again about what we did here. So we created a generic function which loops over an input array. And then we gave it a function as an input, which is used to calculate something based on each element of the array. And we have created a bunch of different callback functions for this, and we could create even more. And this is way better than having one big function calculating all of this stuff at the same time, because it creates more modular and readable code. So each function here, of these three that we coded here, each one has a simple and single task. So this is a really good practice. Okay, so this was an excellent use case of why and how we should make use of the fact that we can pass functions around just like variables. So with this simple technique, we wrote some cleaner code, and this code is more reusable and readable, which is really cool. All right, see you in the next lecture. After functions accepting functions as input, let's now talk about functions returning functions. And to learn how to do that, let's create a function that creates different interview questions for different jobs. And this is how we're going to do it. For each job, we will return a function that builds a string using the person's name as an input. So basically a function returning another function. So function, let's call it interview question, and it will accept a string which is a job. And then in here, according to each of the different jobs, we will return a different function which will then log a question to the console. So we're going to do an if-else statement here. So if the job is designer. Okay. Then return, and here comes the fun part, because we will simply return a function which will accept the name, and then in here we put our code. So this is basically an anonymous function, right? So this function here, it's an anonymous function because it doesn't have a name. So all of this is what we're going to return if the job is a designer. So console.log, and the interview question for a designer will be first the name, because we will pass that into the function, right? So here is the name parameter, and then let's ask the person, can you please explain what UX design is? So user experience design. Okay, and now another job, let's say a teacher. So teacher, and in here we again return a function, an anonymous function again, which also accepts a name and then a similar string, so console.log, and then it's a teacher, so let's ask the teacher in the interview, what subject do you teach? And then maybe the name of the person. Okay, now we could continue this with a lot of jobs, or we could even have used a switch statement, right? But I don't want to overcomplicate things here, because this is just for demonstration. So I'll just leave these two, and then here an else statement. And again, we're going to return a function, and in here we'll once again console and then ask hello, then the name, what do you do? So just a random question if we don't know the job. Alright, so this function here that we just wrote will not just return a simple value as we usually do with functions, right? So instead it returns an entire function that we can then use later. And this is possible because functions are always first-class functions in JavaScript, because they are effectively objects. So we simply actually return an object here, right? It's simply an object that happens to be a function. So let's now use this. And remember, this returns a function, so we have to store the result somewhere. So let's create a variable, and I will call this one a teacher question. So this means it will be a question always for teachers. So now interview question, and then what I pass into it is the string teacher. And now if I run this, then this teacher question variable here will be the function that is returned from the interview question when we pass teacher. Where is it? So here. So again, this variable teacher question down here will now be this function here, right? This is just like when we store a function expression in the variable. This is the exact same thing, right? So let's now use this, and I'm going to say teacher question and the name John. So I'm now calling this variable here, which is a function, and I will put the name John into it here, right? Because as we know, this function accepts a name as an input. So let's see what happens. Alright, so what subject do you teach, John? Exactly as expected. So with this method, we can basically write one generic function, which is the interview question in this case, and then create a bunch of more specific functions based on that generic function. And in our case, that's this function here, the teacher question, which produces questions for teachers. So we can now also create a function which produces questions for designers, right? So let's say designer question. And then again, we simply call the interview question function, right? But this time with the designer as the argument. And now we have a function which is for designers. So let's console log this here as well. So designer question, and again, John. Let's console log this. Okay, so I misspelled something here. All right, so it's question. Okay. So, John, can you please explain what UX design is? So once again, we have now created a bunch of more specific functions here. So the teacher question and the designer question functions based on our more generic function, which is the interview question function. And we could now go ahead and use this as many times as we want. So let's say designer question for Jane, and for Mark, and for Mike. And to get the point, right? So we can now use this for as many, let's say, designers as we want. So Jane, Mark, and Mike. So all of them will get this question. Let me just show you now that we could also have done this in a different way. So let's say interview question. Okay. And then teacher. And as you know, this will return a function, right? So this will return this function here. And we don't even need to store it in a variable. We can call it right away. So we can use the parentheses once again and then put, let's say, Mark in here. So this looks a bit strange, but it works. And that's because this is evaluated from left to right. So first this part here, so the interview question function gets called, it returns a function, and then with this here we call the function that was returned before with Mark. So let's see. And yes, this still works. What subject do you teach, Mark? Alright, so this is of course a really simple example, but it shows you how useful this technique can be. And it really takes some time to getting used to this way of thinking and using functions. But once you understood, it can be really powerful. Okay, and once again, I really want to encourage you to try this out on your own, write your own functions, and do some experiments with these new concepts of first-class functions. And after that, you can just proceed with the course. So see you then. Welcome back. I hope you're still following along just fine. In this lecture, we're going to talk about an extremely common pattern in JavaScript, and that is immediately invoked functions expressions, also called IFI. Imagine that we wanted to build a little game where we win the game if a random score from 0 to 9 is greater or equal to 5, and lose if it's smaller. So just a small and silly game really. But we want to keep the score hidden in this game, okay? So the score should not be visible. Now I'm sure that you can think of a way of doing this, right? And the answer is to write a simple function, because we already know that variables defined inside of a function cannot be accessed from the outside scope, right? Because the scoping chain only works the other way around. So we could simply write something like this. So function game without any parameters, and then calculate a random score, right? So math.random times 10, so between 0 and 9, and then simply log to the console if the score is greater or equal to 5. So just a really silly game, right? Then call it, and then let's see. Okay, so false. So this doesn't really matter here, because what I want to show you is that we can do this in a different way. Because there are a few problems with this. If the only purpose is to hide the score variable from the outside, so which means creating a private variable, then we don't need to declare a whole function with a name and then call it. We can do this in a better way, and that is to use an immediately invoked function expression, which is usually abbreviated as IFI. So let me first write out how an IFI looks like, and then I explain you how and why this works. So we start with parentheses, and then in here we simply write our function, and actually our anonymous function, so without a name. Okay, and then let me just actually copy this. There's no need to write it again. Okay, and then we just invoke this function like this, and this is it. This is an iffy. So how does this actually work? Let's start at the beginning. So if we just wrote something like this, so function, so just something like this, so without the name, but also without the parentheses, then the JavaScript parser would think that this is a function declaration. But since we don't have any name for the function declaration, then it will throw an error. So we basically need to trick the parser and make it believe that what we have here is an expression and not a declaration. And the solution is to wrap the entire thing into parentheses, because in JavaScript, what's inside of parentheses cannot be a statement. And like this, JavaScript will know that it should treat this as an expression and not as a declaration. And then after that, we only have to invoke the function, because if we didn't do this, so if it would be like this, without the parentheses, then it would never be called and never do anything. And since we don't attach this to a variable, then nothing would ever happen. So, does that make sense? This is just how the iffy works. And just like this, we can no longer access the score variable from the outside. So we created data privacy here. And let's confirm that actually. So let me remove this. So let's try to console log the score, but we already know that this is not going to work, right? So let's take this out here, okay. Alright, so we have true, which is the result of this iffy, and then score is not defined, of course. So outside here in the code we cannot see the score variable. We can of course also pass arguments into the iffy. So we could extend our function by adding a parameter called good luck to the game. And the more good luck we add to the game, then the higher the chance that we win the game. So very simple, let's just copy this, just to show you that we can use a parameter here. So let's call this good luck, and then we subtract the good luck here. Okay, so makes sense. So the more good luck we add here, imagine we had 5, then 5 minus 5 would be 0, and then the score would always be bigger than 0, and therefore we would always win, right? And how do we now pass the argument into the function? Right, we just need to add it here. So let's use the example of 5 that I just gave you here. Okay, so let's just reload this. And now it didn't work because we have the error here. So we first need to take out this part, and then true and true. And of course, the second one will always be true. So as you see, we can of course only call the iffy once, right? Because this function is not assigned to any variable. But that's no problem at all, because in this case we are not using the function to create a piece of reusable code. All we want here is to create a new scope that is hidden from the outside scope, so where we can safely put variables. And with this we obtain data privacy and also don't interfere with other variables in our global execution context. So if this is the goal, so if this is exactly what we want, then the iffy is the perfect solution. So again, this is not to create a piece of code that we will reuse. This is just for data privacy. Alright, so this is going to be yet another very useful tool in your JavaScript toolbox. This was, of course, just a toy example, but later in our project we will see how important this iffy pattern is in real-life applications in order to structure our code and obtain data privacy and code modularity. So let's now move on. We have learned a lot of theory up until this point, but now you are ready to understand one of the most crucial and advanced things about JavaScript: closures. And this is probably one of the most difficult to understand topics for beginners. But you already know everything that you need in order to understand and use closures. So let's dive right into this lecture. So as our example for this lecture, we want to write a small function that returns a function which calculates how many years we have left until retirement. So let's quickly do that. So function, and let's simply call it retirement. And we pass into it the retirement age. So the age at which someone can officially retire. So for example, here in Europe, it's mainly 65 years, usually. Okay, and this function will then return another function which will actually calculate the years that someone has left. So we already did this in the last lectures, so let's not do it again. So we simply return an anonymous function here. So we don't have a name, all we have is a parameter, and this is the year of birth again. So we start by calculating the age in here, so 2016 minus the year of birth, and then we log to the console the retirement age that we passed into the first function, right? Minus the age that we just created. And then let's add something else, like a string, to make a sentence out of this. And I'm calling this one A, which I didn't declare yet, so I'm going to declare it here. So var A years left until retirement. So I will explain you in a second why we actually wrote this function like this. It's because we want to use closures here. So I will explain you in a second what closures are and how they work in here. But for now, let's just write this function so as it is. And now let's try to use this function. And as you know, this returns a function, so we can store the result of calling this function in a variable, and then this variable will be a function as well. So as you noticed, we passed the age that someone has to have in order to be able to retire. So this is an age that changes from country to country, and so we can basically create one function for each country. So this is similar to creating the interview questions for different jobs like we did before, right? So let's create a function here for the US. And I know that in the US the retirement age is actually 66. So we call our retirement function and then we pass 66 into it, and this will return a function where the retirement age, so this here, is 66. So if we now call our newly created function, which is this one here, right? So retirement US, and of course we need to pass the year of birth, right? So let's use our well-known 1990, okay? And then let's check it out. Alright, so 40 years left until retirement. Or we could also write it like this, like we did before. So for example, retirement, then pass an age, like 66 again. So this will return a function, and then we can simply call this new function with a year of birth again. So this should give us the same result. Okay, so 40 years again. So this works. And let's take a look at what just happened here. So let's examine this together. So we started by calling the retirement function and passed the value of 66 here, right? The function then declares this a variable here and returns this function. Then the function finishes and its execution context gets popped off the stack. And you remember that part, right? Okay, so we stored the returned function here in the retirement US variable, right? So here we call it. And now comes the cool part. So in here, in this function, we use the retirement age parameter of this outer function here, and also the a variable that is also declared outside of this anonymous function. And still, when we run this, this works. So somehow we are able to still use these variables even after the retirement function, which declares these variables, already stopped its execution. So think about that again. Our inner function here is able to use the retirement variable and the a variable of this function here that is already gone. It has already returned, but somehow the variables are still there. And this is the closure. This is really fascinating, right? This really blows my mind each time that I use it, really. So now that we know what a closure is, let's see how and why this actually works behind the scenes. So again, we can summarize how a closure works like this. An inner function has always access to the variables and parameters of its outer function, even after the outer function has returned. So let's see what happens when we call our retirement function. As we already know, the new function gets a new execution context that is put on top of the execution stack. That execution context has an object, which stores the variables, the scope chain, and the this variable. So let's see the scope chain for the retirement function, which means the variables that the function has access to. And remember, the scope chain is like a pointer to all the variable objects that the function has access to. Alright, so of course, the function has access to the retirement age argument set to 66 and the a variable that holds our string. Okay, and then the function returns. So after the function returns, now the execution context of the retirement function is effectively gone. And with it, the variable object and the entire scope chain should be gone, right? Actually, no. The secret to closures is that even after a function returns and the execution context is gone, the variable object is still there. It's not gone. It still sits here in memory and it can be accessed. And that's why we still see it there in the execution stack on the left side. And also in the scope chain on the right side, because, and I'm sure that you remember this, the scope chain is in fact a pointer to variable objects. And in this case, the variable object that we have here on the stack. So let's see this in action. Let's call the inner function that we effectively called retirement US with the argument of 1990, which puts, of course, a new execution context on the stack. Let's now look at the scope chain. So since this inner function is written lexically in the retirement function, it gets access to its scope. And you already know and use that. And now here comes the magic. Since the variable object of the retirement function is still there, the scope chain stays intact. It keeps working. And so we can access the variables that were created in the retirement function long after the function has completed execution, and after its execution context is of course gone. The current execution context has closed in on the outer variable object so that it can use it, and that's why it's called a closure. So the scope chain always stays intact. This is the most important thing that you have to understand and remember. Okay, and just to finish this, the function simply returns and the context is popped off the stack, as usual. So now you not only know what closures are, but you also know how and why they actually work. And note that we don't create closures manually. This is something that's really built into JavaScript. We don't have to worry about anything. We don't have to say that we want a closure. JavaScript will always do this work for us automatically. And now this summary makes even more sense to you, right? So an inner function has always access to the variables and parameters of its outer function, even after the outer function has returned. So let's now see how this function that we created can be useful for us. So we can create 3 different functions for countries with different retirement ages and use these functions over and over again. So this is similar with something that we did before, right? So we have a more generic function up here the retirement function, which we can then use to create more specific functions. And this is only one of the many application cases of closures. And we will see more of these later on in the course. So let's now create some more functions. We just get rid of this here. Okay, so let's create a retirement function for Germany. Because in Germany, the retirement age is not 66, but 65. Okay. And we can also create one for another country here in Europe, which is Iceland, which has an age of 67. So Iceland, we will call the retirement function with an argument of 67. And now we can go ahead and use these functions for different people in these different countries, for example, and see how many years they have left. So let's use these three for the same people, imagining that they lived in Germany. So the retirement Germany function, and that they lived in Iceland. So retirement Iceland, and then also 1990. And if I now run this, we have 3 different ages. Actually 3 different years that the person has left until retirement. So 39 in Germany, 40 in the US, and 41 in Iceland. And all of this is possible thanks to the power of closures. Okay, now just to finish this, I have a very small challenge for you. And this challenge is that you should rewrite the interview question function that we wrote in another lecture, but this time using the power of closures. And the function that I'm talking about is, let's see, yep, it's this one here. So let me copy it, paste it here. Okay, and I'm going to comment it out. Okay, so again, I now want you to write this using the power of closures. So please pause the video now and do that, okay? Okay, so I hope that you managed to do it. So let's now see the solution. So of course, we again write a function, and it's again called interview question. And we still accept the job. But now the difference is that we will always return the same function. So there's only one return keyword in here, okay? So one function which accepts the name, and then we do our if-else statement right in here. And that is possible because of closures, because we will be able to use the job argument, this one right here into this function, even after the interview question function has returned, right? So let's now write our if-else statement in here. So job designer, and I will then copy the code from up there. So, and then else if job is teacher, and then the else part. Okay, so if it's a designer, it's this code. There's of course no need to write this again. Then this is for the teacher, and this is for all the other jobs basically. Okay, so let's now use this function for a teacher. So interview question, let's say teacher, and then we can call it right here. There's no need to save it in another variable, as I already showed you, right? And let's now run this, and it works. So what subject do you teach, John? So we see this is clearly a question for the teacher, right? So again, the difference between the two functions is that now the decision is taken right inside of the function that we return. And that's possible because we can use the job variable to take this decision here, even after the interview question function has already returned. So when we first wrote this function, we didn't know about closures, so we wrote it this first original way here, right? But now we don't need this anymore because now we know about the power of closures, right? And so we can harness that power and effectively use them. Because this is a better way of doing it. This is cleaner code. So we have only one function and then the if inside of here. So let me explain it one last time, okay? So this function call here will return this function here, okay? And then we call this function with the John parameter, the John argument, and then this execution context will close in over the variable object of the function that we had before, that we called before. So it will close in on the variables that we defined in the old function, which was the job variable. And so we can use this variable right into this function as well. And we do that in here. So here in our if-else statement, we use the job variable of the interview question function that has already returned by the point that we use this inner function here, right? So now I hope that this is crystal clear to you. Alright, and this was closures. And as you have seen, they allow us to do really powerful things, and you will see that in our project later. So make sure that you really understand closures. And I hope that you can see now why it was so important to learn all the JavaScript theory that I showed you before. Because without that, you would not be able to understand what I just showed you in this lecture. Because this was really, really advanced stuff. So if you actually understood this lecture, then nothing can stop you anymore on your path to become a really amazing JavaScript developer. So how cool is that, right? In this lecture, we will expand our JavaScript toolbox even more with the bind, call, and apply methods. So we know that functions are a special kind of object, right? And such as the array objects, for example, functions also get a couple of special methods which they inherit from the function constructor object, right? So in this lecture, we will talk about the powerful call, apply, and bind methods. And in a nutshell, these methods allow us to call a function and set the this variable manually. So let's see a small example here. And for that, I'm going to create an object. And in this case, it's just a very simple object. So no fancy function constructors or inheritance, none of that stuff. So just John and then the object literal syntax. So his name is John, of course. And we've done this a lot of times by now. His age. And then his job, which is a teacher. And now what we also want here is a method, and that's a method basically for John to present himself. And we are going to have two styles here. First a formal style and then also a friendly style. So John is basically going to say a sentence in which he presents himself. And we will also make this dependent on the time of the day. So presentation is a function which accepts the style and the time of day. Okay, so depending on the style that we chose, we will have two different sentences. So if the style is formal, then we console log something. And if the style is friendly, then we say something else. So console log something else. Okay, in the formal part, we are going to say something like, good morning, ladies and gentlemen. So good, then the time of day, ladies and gentlemen. And now remember, if we want to have this symbol here, then we need to actually escape it so that JavaScript thinks that it's not closing the string, but that it's really part of the text. So I'm So and then his name. So I'm John in this case. Then we want to say how old. So I'm, or let's actually first say his job. So I'm a this.job. So I'm a teacher in this case. And I'm, and now the age. Years old. So a bit confusing, but it makes sense. So now if the friendly style is chosen, then we want to start our sentence with something like, hey, what's up? And then again, I'm, and now we can actually copy this. And I see I'm missing a plus sign here. So let's copy this. So then close it. And I also need to use the time of day. So have a nice plus time of day. Okay, so first of all, let's test this. So John.presentation with the formal style, and let's say in the morning. Okay. Okay, so it looks good, right? Actually, there's only one space here missing, but the rest is good. So it's just here, a space, right? And so also here. Now let's add another object here for someone called Emily. So the name is Emily. She's 30 years old, 35. And she is a designer. Okay. Now, suppose that we want to use the presentation method for the Emily object, which does not have this presentation method, right? We can use the call method to do this. So how does this work? The first argument of the call method is always to set the this variable. So let's see this. So we can say again John presentation, and now we use the call method on this function, on this method here. So call, and now as I said, the first argument here is the this variable. So if we set the this variable to Emily here, right, then the this variable here and so on, then this will no longer be John, but it will be Emily, right? And now we can set the other arguments. So let's this time use the friendly style, and it's in the afternoon. So let's check this. And it works. So now it's Emily and it still works. So we have the job and her age. And this is called method borrowing, because we actually borrowed the method from John to use it here on the Emily object. So again, the call method allows us to set the this variable here in the first argument. And we set it to Emily because we wanted to use John's presentation method, but setting the this variable to Emily so that we can use John's method on Emily, right? So that is the call method. There is a very similar method which is called the apply method, and the only difference is that this one accepts the arguments as an array. So there's only two arguments, first this variable and then an array where all the other arguments go. So it would be something like this. So John done presentation and apply in this case, and Emily, and now as I said, the array. And then in here we would set the other arguments. Friendly and afternoon. Now this is not going to work because our method does not expect to receive an array as the input, right? So the presentation wants two normal arguments here. It doesn't expect to receive an array, so this is not going to work. But I just wanted to show it to you because we will actually use this later in our project. So let's just comment this out here. Alright, and let's now see the bind method. So we use the call and the apply. So the bind method is the one that's missing here. So the bind is very similar to the call method as well. So it also allows us to set the this variable explicitly. However, the difference here is that bind doesn't immediately call the function, but instead it generates a copy of the function so that we can store it somewhere. And that can actually be extremely useful to create function with preset arguments. So let's see how. So let's create a variable because, as I said, the bind method will return a function. So we have to store that function somewhere. So we're going to use the bind method to create a function with preset arguments because bind allows us to do that. So we're going to preset the friendly argument so that we don't have to input it again and again. So let's call this function John friendly. Okay. John.presentation. And now I'm going to use bind. And again, the first argument here is to set the this variable, which in this case doesn't really matter. So I'm just going to go with John. Okay. And now I say friendly. So this is the first argument of the function, of the presentation function. So the style. But I will not set the time of day, okay? This will not be set here at this point. I will just leave it like this. So let's now use the John friendly function. Because again, this method here returns a function. So the function will get stored here in the John friendly variable. So John friendly. And now there's only one argument left to be set, right? Because I already set the other one as friendly. So I can now say like morning here again. And this is just going to work as it did before. So let's see. Alright, so I'm John, a teacher, 26. Have a nice morning. So you see how useful this is, right? So we have a function now which is always for the friendly version of the presentation method. So we can now use it for another time of the day. So John friendly again. Now let's say in the night. And again, everything that changes here now is night. So again, bind allows us to preset some arguments here. And this, what we just did here, actually has a name and it's called currying. So currying is just a technique in which we create a function based on another function, but with some preset parameters. So exactly what we did here. And bind is extremely useful for that. And we can of course do the same for Emily. Okay, so let's say var Emily informal. So John.presentation and then bind. And this time the this variable matters again because we need to use the presentation method on Emily. So the this variable will become Emily. And now I'm going to preset this argument to formal. And I can now use it. So Emily formal and then afternoon, for example. And here we go. Good afternoon, Emily, designer and 30 years old. All right, so now we saw some example for call, apply and bind. Once again, these are more like small toy examples, but they really help you to understand what we can do with call, apply and bind. And we will actually use them in real situation in our next project. But before doing that, I want to just very quickly show you a cool real-world example right here. So let's bring back some of the code that we wrote in a lecture about passing functions as arguments. So I have the code up here. Let me see. Oh yeah, this is the one that I want. And this one here as well. Okay, so let's create some space here. And all right. Okay, and do you remember this one? So this was the function that we created here, where we then passed a callback function, which was to calculate age and calculate if someone was of full age. So imagine this like a machine which accepts a function and then applies that function to all of the elements of an array, right? So back then we had this full age function here. But actually the full age varies from country to country. So it's not always 18 years like we have here. For example, in Japan, you have to be 20 to be of full age. And in other countries, it's actually something like 16 or 17. So what we can do is to pass in a second argument for the age limit. So something like this. So we pass in a limit, and then instead of having 18 here, we say that the element in the array has to be greater or equal to the limit that we defined. Alright, so let's again start by calculating the ages. So var ages is array calc, then the years array, and then our callback function calculate age. Now, the problem with our full age function is that it accepts 2 arguments, but our array calc function here can only use it with 1 argument. So here, right, the fn function is always called with only 1 argument, which is this element of the array, right? So what can we do here? I would say that the best solution is to pass in our isFullAge function, but with the limit already preset, right? And that's what we're going to do. Do you remember how to do that? Exactly. We use the bind method, because bind allows us to create a copy of a function with a preset argument, which is exactly what we need here. And we did that before, and so now we're going to do it again. So let's create a variable again called full, but this time it's called full Japan, because I'm going to do it for Japan, because they have this limit of 20 years. So this is what we did before also. So array calc, and now we pass in the ages that we calculated before. And now we cannot simply pass in the isFullAge, as I explained before, right? So isFullAge. So we will not just pass this function like this, but we will use the bind method on it before passing it. So now we can preset the argument. So first the this keyword, don't forget this, the first thing always has to be the this keyword. And in this case, we don't really care about it. So we just say this, and then our preset limit, which is 20. Okay, and now what will be passed into the array calc function is not simply going to be the full age function, but a copy of the isFull function with 20 as the preset argument for the limit. So let's see if this actually works. So let's console.log the full Japan. And also let's show the ages so that we can see if this is actually correct. So ages. Okay, so yes, it seems like it's working, because here we have someone which is 18, right? But our isFullAge function tells us that this person is not of full age here, right? And that makes sense, because in Japan you're only full age when you're 20, as we specified here. So this is working. And this is another very useful way in which we use the bind method, and this is really a real world example. Cool, so now you have yet another tool in your toolbox. And that toolbox is getting really, really full, right? We are now almost ready to start our big project. So let's very quickly move on and see you in the next lecture. Hello there! It's time for another coding challenge, so that you can apply some of the concepts that you just learned on a fun and practical coding exercise. So in this challenge, we're gonna build a fun quiz game right here in the console. So you see here in the console we have a question, and then in here we have this pop-up window where we can insert the correct answer. So there's no fancy user interface, we do everything just here in the console and using this prompt window. So in here we can select the correct answer, and the question is JavaScript the coolest programming language in the world? And yes, of course it is, right? So let's insert 0 here, okay, and then correct answer. So if you want to play again, we just reload the page, we get another question, and right now I only have 3 questions, and these are selected randomly, so it's very likely that we have the same questions again. So 0 again. Let's reload this again. And now we have a new question. So what's the name of this course's teacher? And yes, you already know, it's number 2, Jonas, right? All right, so you see how this works, right? So let's check out some instructions for this challenge. So again, let's build a fun quiz game in the console. And the first step is to build a function constructor called question to describe a question. And the question should include, of course, the question itself, right? And then the answers from which the player can choose the correct answer. And in here, you should choose an adequate data structure, like an array, an object, or whatever you think is best. And then also, we need to store the correct answer so that we can check if the input answer is correct. And for this one, I would use a number. Okay, and then when you have the function constructor properly set up, you can then use it to create a couple of questions. And then number 3, store all of these questions inside an array, because that makes it a lot easier to code step number 4, which is to select one random question and log it to the console, together with the possible answers, of course. And then each question should have a number, such as we saw in the demonstration. And the hint that I can give you for this is to write a method for the question objects for this task. Then after that, you use the prompt function to ask the user for the correct answer. And the user should then input the number of the correct answer. And these numbers are of course the numbers that you displayed in task 4. And then finally, you check if the answer is correct and print to the console whether the answer is correct or not. And I would write another method for doing this. Now in the end, suppose that this code would be a plugin for other programmers to use in their code. And so we have to make sure that all of your code is private and doesn't interfere with the other programmer's code. And we learned a special technique in this section to do exactly that. So use that one to complete this step. So this is the most basic version of the quiz, but this time I also have an expert level. And so let's take a look at that first, and then let's see the instructions here. So this time, after we answer to one question, we will always get a new question. And we also keep a score and display it so that we know how many answers were correct. So again, what is the name of this course's teacher? And number 2, Jonas. And you see, we get a new question right away here, right? So we see correct answer, then your score is 1, because we have 1 correct answer at this point, and then we get the new question here. So is JavaScript the coolest programming language in the world? And yes. Okay, so now we have 2 points. So what's the name of the course's teacher again? So let's now put a wrong answer here. Let's say 1. And then wrong answer, try again, and our current score keeps at 2, such as it was before. So this question again, so number 2, 0. And here is the third question that I wanted to show you. So what does best describe coding? It's boring, hard, fun, or tedious. So the answer is of course number 2, right? And now our current score is 5. So this version of the quiz is a lot more fun, right? So let's see the instructions for this one. So after you displayed the result, you should display the next random question so that the game never ends. And if I were you, I would write a function for this and then call it right after displaying the result. But be careful, because if you do that, then the game will actually literally never end. And so you have to include an option to quit the game if the user writes exit instead of the answer. And then in this case you don't call the function here in task 8. So let me actually show that to you. Okay. Because if I hit cancel, then I will always get a new window. You see? And I cannot close this. And so the only way to exit this game is to write exit here. And that's because I coded it this way. So exit, and then the game ends. Okay, so you have to code this too. Now after that works, you can track the user's score to make the game even more fun. So each time that the answer is correct, you just add 1 point to the score. And for this task, I am actually going to use the power of closures. But of course you don't have to, you can do it in another way. Because for me, the most important thing at this point is that you actually write the code on your own. So that you really try to solve these problems on your own, okay? So it's absolutely no problem if your code is different from mine. The most important thing, again, is that you should really do it on your own at this point. Because right now in the beginning of your journey, the most important thing is that you really practice and that your code works. Then optimizing your code to make it perfect comes after that. But for now, just get your hands dirty with some coding and not trying to make it perfect, okay? Then finally, in the end, just display the score in a console such as you saw in the demo before. And for that, you can use another method. So again, just try to code this on your own. And then after that, once everything works the way I showed you, you can check out the solution to see the way I implemented this game, okay? So good luck and take all the time that you need. So, I hope that you took the time and completed the coding challenge and made the quiz work. Now, if you want to see my solution, then here it goes. So let's start with step number 1 and build our function constructor down here. So, function, question, and as we already saw, what we need as inputs here is the question, the answers, and the correct answer, right? So I'm simply giving it these names. So question, answers, and the correct. Alright, and now this is how the function constructor pattern works. So we set everything that we input into this constructor on the this variable of this function, right? So this dot question is the question that we input. This dot answers, the same, and the same for correct. Alright, and that's it. That's our function constructor. So let's now use it and create a couple of questions. So var question 1 is a new question, and in here I'm going to pass first a question, right? So I'm going to go with the ones that I showed you in the demo. So is JavaScript the coolest programming language in the world? So that's the first argument. Then the second argument are the possible answers. And I'm going to choose to use an array for this, because that allows us very nicely to store all of the different options in one single variable. So in here, we only have 2 different options, which is yes and no. Okay, and the third one is the correct answer, and that is number 0. So remember, an index is 0 based, and that's why I'm going with these 0 based correct numbers here as well. So the first one is 0, and the second one is 1, and so on. And with this, we created our first question. Now, remember why that works. It works because the new operator here creates a new empty object, then it calls the question function and sets the this variable of this function to the new empty object that was just created. And therefore, when we then set all of these properties of the this variable, these will be assigned to the this variable of the new object. And that new object will then be stored here in the Q1 variable, right? Or as you already know, actually, the Q1 variable will hold a reference to the spot in memory where the object sits, and then we can of course use our newly created object. So let's now create another one. So question 2. So the second one was, what's the name of this courses? And remember, I have to do it like this. So I need to escape this symbol so that JavaScript doesn't think that it's the end of the string, teacher, and now the answers. So John, Michael, or Jonas. And as you see, we can have different numbers of answers. So here we had 2, here we have 3, and in the next question we're actually going to have 4. Okay, and in here the correct answer will be number 1, obviously, right? Because the index is 0 based, and so this last one here is 0, 1, 2. Alright, and let's create a third question. So var q3. And now, what does best describe coding? So is it boring, or is it hard, or fun, or maybe tedious? And I would say that it's number 2, so it's really fun. So 0, 1, and 2. Alright, so we just created 3 questions. That should be enough for now. Of course you can add more to make it more interesting, but just to show it, it is enough. Now number 3 and 4 is to store them in an array and then select one random question. So let's say questions is of course Q1, Q2, and Q3. Alright, and now we need to retrieve a random question from this array. And so the first thing is to create a random number, which we can then use to take the question. So we want the number between 0 and 2, right? So 0, 1, or 2 should be the number of this random question. Now in case that you have more questions, of course the number will be higher. And so we need to write code that gives us a random number between 0 and the number of questions that we have, right? So let's do that. And I'm going to call this number simply n. Okay. And as we did before, we're going to use the math.random method, which remember returns a number between 0 and 1. But we don't want between 0 and 1, but between 0 and the length of our array. And so we multiply it to make it a bigger number. And we multiply it by the length of the questions array. So length. So now we just need to use the math floor, a method such as before, to remove the decimals from this number. Because remember, this will give us something like this. So let's see it in the console. Okay, of course it doesn't work like this. So let's say we know that the length is 3, right? So let's simply do it like this. So this is going to give us a number between 0 and 3, like this, right? And so we want to simply cut out these decimal part here. And that's exactly what the math.floor method does. And this way our number will always be nicely between 0 and 2. Okay, so now writing questions, n will give us a random question. Now all we need is a way to display this question in a console, right? And so as I mentioned before, I'm going to use a method for that, right? And so we're going to use the concepts of prototypes and prototype chain to write this method. Because I should not write this method right here into this object, right? Because then all of these 3 questions would have this method attached to them. And that would not be ideal. So remember what we discussed in the lectures before. And so what we talked about in the lectures before is to write the method into the question's prototype property, which is the prototype of all of the instances, so of all of the objects created through it. So of Q1, Q2, and Q3. And it works like this. So question.prototype, and now the name of the method. And this one is going to be simply display question. And the first thing is of course to display the question, so console.log. And this dot question. So when this method will be called on Q1, then the this keyword here will of course point to key 1, right? And then a question associated to Q1 will be retrieved. If we call it on Q2, then the this keyword here points to Q2. And of course the same thing with Q3. So that's the cool thing about the prototype chain, that this method is not actually attached to one of these questions, but it's in their prototype. And so all of these objects can access it through the prototype chain. Okay, so this displays the question. Now we need to display the answers. And since we have multiple answers and we also don't know how many these are, so in some cases we have 2 and here 3 and here even 4, we need to loop through all of these answers and display each of them. So we're going to use a for loop for that. So var I equals 0 and then I will be incremented until we reach the length of the answers. Dot length. Okay, so we did this a lot of times before. And e++. So imagine that there are 2 answers, then the length will be 2, and so this will run when I is 0 and when I is 1. And then when it's 2, this condition here no longer holds true, and then the loop stops. And so in here what we're going to do is to console.log each of the answers. So this dot answers, and then we're going to retrieve in each iteration the corresponding answer. But actually we not only want the answer but also the number. And so for that we're going to use this I counter variable. So it's going to be 0 and 1 in this case. So we want this, then we want to add a colon and a space and then the actual answer. Okay, so this should already work. So let's test this out. So with this here, we already retrieved the random question. Now all we need to do is to call the display method on it. So display question. Actually, I need to call it, right? And so now it's time to test this. And we have a bug in line 335, but it's no problem. Let's see where it is. Yes, of course. The assignment operator is missing. And another one. And yes, of course, that's because I'm still missing here the function keyword. Okay, so this was totally missing, of course. You probably saw it coming already. And again, another error here. Now it should work. So the question is already here. So JavaScript, the coolest programming language, but the answers are missing here. So something is wrong in here. And so the problem is here. I misspelled this one. And now here we are. So yes and no. So let's reload this. And yeah, it works for the other questions as well. So here are our 3 random questions. Let's check out the next step. So now we use the prompt function to ask the user for the correct answer. So we're simply going to do var answer. And then remember this prompt function that I showed you right in the beginning. All it does is to open like a pop-up window where the user can input something. And what we pass in here is simply the string that will be the question that we want the user to see. So please select the correct answer. So let's test this. And we say 0. So now of course nothing happens because we didn't yet code the part that validates the answer, right? But before we do that, let me show you something. So I will just log the answer here. So answer. And what you see now is that this is actually a string, right? If it would be a number, it would look like this. So it's blue and it doesn't have, of course, these quotes. So this is really a string and not a number. But the correct answer that we have here in our questions are, of course, numbers. And that's what we're going to compare the user's answer with. And so therefore, this also has to be a number and not a string. So what we can do is to use the JavaScript built-in function called parseInt. So parseInt, and this simply converts a string to a number, to an integer number. So parseInt, actually with E. And now let's see this again. So number 2, and let me check the answer here again. And now you see it's a number. So it no longer has these quotes, and it's displayed here in the blue color. And now to check the answer, if it's correct, we are going to write another method here into the prototype. So question.prototype.checkAnswer. So what should we do here? It's actually very simple, right? All we need to do is to compare the answer that the user gives with our correct answer, right? And so we need to actually pass in this answer into this method. So let's simply call it ans. Okay. And then in here we just need an if-else statement. So if the answer from the user is the same than our correct answer, then we console.log correct answer. And if it's not, then we simply log wrong answer. Try again. And that's it. So now all we need to do is to call this method down here. So again, we use our question that we are working on, and that is questions n. And then we use check answer and pass in the answer from our user, which is stored in this answer variable. We could of course have stored this here in a separate variable because we're using it here and then again here, but let's just leave it this way here for now. And now this is actually all we have to do to make this work. So let's test it out. So is it the coolest programming language? Yes, it is. And that's the correct answer. Cool. And the same question. And again, the same question, what's going on here? And now we have a different one. So what does Bass describe coding? It's fun and correct. Just to try another answer here. And now it's wrong. All right. So let me see the tasks up here actually. So we completed all of them except number 7. And this one tells us that we should give our code a privacy so that it doesn't interfere with other programmers' code. So what did you learn in this section to do exactly that? That's correct. We're going to use an immediately invoked function expression. And it's really simply, we just have to do function just like this, and then invoke the function at the end. And this creates a new scope in which we define all of this that we did here, right? And then at the end, the function is simply executed. And so if now someone else includes this code in his own project and also has a variable called question or a variable called n or answer, then that one will not interfere with our code. So our code is always safe because no other code is ever going to override it. And that's the main goal of using an IFI like this. So this is really a great use case to show you how important this can be. Let's just test it again to see if it still works. And yeah, of course it does. So that was the first basic level of our quiz. Now in the next lecture, I'm going to show you the solution for the expert level quiz. So stay tuned for that. Alright, so here goes my solution to the expert level of our small quiz app. So let's first take the code that we just wrote and copy it down there. So I'm going to comment it out and copy it. Alright, and paste it down here. So this is a starting point to now code the expert level of the quiz. So let's take a look at our first task here. So after we display the result, we then want to display the next random question. So let's do that and simply write a function. And what this function is going to do, it's going to do all of this game logic here so that we can call it over and over again. So let's call this function next question. So function next question. And of course it doesn't need any parameters. And now let's put this to the inside. And then of course we need to call it next question. Okay, so right now this is actually exactly the same thing that we had before, so nothing different is going to happen. Because now we need to also call this function here in the end. So imagine we execute this function here, and then after all of this is done, so after we selected our question, displayed it and checked the answer, we simply want to call this again. So very simple, we simply write next question again. Actually this part here, we only need to do once, right? So the array of our questions is always going to be the same, so nothing changes there. Now remember the problem that I described, which is that right now, if we would call this app like this, then we would have no way to actually ever stop this quiz. Because each time that we hit the cancel button on our prompt window, it simply opens a new one. And then there's no way to really stop this. So we have to have a way to stop the game. And that is by writing exit into the prompt window instead of writing the number for the correct answer. And so let's say that we only want to call this next question if the input from the user is not exit. Okay, so we say if the answer is different from exit, only then we want to call the next question again. So this makes sense, right? And actually we also want to only do this one if the user doesn't choose to exit the game, right? So we only need to check if the answer is correct if the game continues. So if it's not an exit. Alright, now before we can actually try this out in the browser, there's still one issue with this. And that is that up here we converted the answer, right, to a number. But here, down here, we want to check if the answer is exit. So if it's this string. And that means that we actually do not want to convert the answer to a number here at this point, because then we can no longer perform this check here, right? Because at this point the answer will no longer be an exit string, never. Okay, so we need to take this out from here and move it. So we are going to move it to here. So parse int this answer. So we're simply moving the parse int function down here, which is where we actually want a number. So we want to pass a number into the check answer method. And so now everything should be set for this to work correctly. So let's try this out. So the name is Jonas, and alright. So you see we have a next question and we have a new prompt window here. So what does best describe coding? It's fun. Correct answer and the next question. So great, it's working just fine. So the first step, or the first two steps actually, are completed with this. Now remember, we need to write exit if we want to exit from this game, right? So let's try that out, so to see if this also works. And yes, it worked. So our code is complete at this point. Remember all of this stuff that we wanted to do again. Here each time after the user gave an input, we simply wrote it in a function, called it at the beginning, and then called it each time that we want to continue the game. So each time that the user didn't write exit into the prompt window. So this was the easier part of this challenge. So let's now talk about keeping the score of the user. And as I mentioned before, I'm going to use the power of closures here in this case. So let's see how. So my solution is to write a function here, which is going to keep the score and to update it when the answer that the user gave is correct. And this is going to be like a nice container where I can keep everything that is related to the score. So the score itself and a function to update it, instead of having like global variables and variable mutations all over the place in our code. So let's just see how this is going to work. So functions, and very simply score. Okay. And in here, I'm going to create a variable called score. So let's say SC, so the short version of score, and 0, just because I don't want to repeat the same name here, okay? And this function here is going to return another function. And what this function does is to increase the score if the answer is correct and then return it. So we actually need a parameter here which says if it's correct. So this is going to be a true or false value. And then if the answer was correct, then update the score. And we know there's a nice operator for that, right? And it's this one. So it's the same one that we always use in the for loops. So this simply adds 1 to the score. And then either way, so if it's either correct or true, it's going to always return the score. Okay. And so this way, everything that I need about the scores is here in this function that this closure returns. Now all I have to do is to call this function and store it, because it returns another function. And so I want to keep that function in this variable. And I'm going to call it keep score. So score, and call it, and that's it. So what's going to happen? Remember what closures are. So we call the score function, it defines this variable, and then we return this function here. And it's going to be attached to this variable. Now, thanks to closures, we always keep access to the variables that the other function defines, right? And so this means that this score variable here will always be accessible by this keep score function here. So this is exactly what we did in the other exercises in the closures lecture, right? So the exact same thing, but now it's applied to this problem, so this application. And up until this point, maybe this doesn't make so much sense to you, so why I use it this way. So let's now see it in action. And it's going to work like this. So we check our answer here, right? So here actually. So we check our answer, and in here we can then call this function that I just defined to update the score if the answer is correct. Okay. And so in order to be able to do that, we need to actually pass this function into this method here, okay? So we're going to make use of the concept that we can pass functions around because they're first-class objects in JavaScript, so first-class functions. So the check answer method is going to be called here. So check answer. And so we're not only going to be passing the answer in here, but also the keep score variable. So keep score, which is the variable that contains the function, and the closure which keeps track of the score, remember. And so now in here we also need to set the parameter. So answer and call back. Let's call it like this. Okay, and now in here we can simply call our function. So it's going to be callback here, but remember that this is the keep score function. And now we pass in true, right? Because we know that here when the answer is equal to the correct answer, the answer will be correct. And remember that this function here, which is effectively stored in the keep score variable here, accepts a correct parameter. So if it's correct, it's going to update the score and return it. And if it's not correct, so if it's incorrect, it's going to only return the score and not make any updates. So in here we always have to pass true or false. And since this returns something, we need to store the score somewhere. So let's say SC again, which is short for score, and then declare it up here. So var score, and that's because I'm going to call the function here as well. So score, callback, and this time with false. And therefore the score is not going to be updated. All this does is to return the current score. And that's because we want to display the score in a console either if the answer is correct or if it was false. So we always need to retrieve the score value from the function, which again has access to it because of the closure. And so let's now write a method for that. So a method which is going to display the score in the console. So question.prototype.display score. Okay, actually we need a parameter here, which is the score. So all we do in here is to simply console.log the score. So your current score is, and then the score, and then simply like a separator line so that we have our questions like nicely separated. So something like this. Okay. And now all we have to do is to call it here. So this dot display question, and then pass the score into it. And once again, we have access to this method here because of the prototype chain. Because this variable here will point to the object on which this method here was called. So this check answer method was called. And then of course it has access to the display score method as well. And so it's called and then prints our current score to the console. So does all of that make sense to you? Let's now check it out if it works. So we know all of the answers by now, right? Well, something is not really working here because this printed 2 questions here now, right? So let's now check out what's going on here. So I'm going to exit the game so that we can check out what's going on here. So everything looks good here actually. Well, what I see here, so here we return a score and not SC. So we were currently returning this function here, okay, instead of returning SC. So this was something really wrong. So maybe that was the reason why this wasn't working properly. So let's check it out again. So coding is fun. So you see that this is still not working fine, right? Because we have still 2 questions here. So this kind of means that the display question here is called twice, right? So this is really wrong. So let's check it out again. So, and I see that here is probably the problem. So here we have display question, which is this method up here, which displays a random question, but instead, of course, it should be displayed a score, right? So in here, we of course don't want to display the question again, but the score. And it's completely normal that these kind of bugs happen in programming, so this is just a matter of a small distraction, and then you can cause these kind of bugs. And then all you have to do is to think about why this is happening, and then try to hunt these bugs down. So basically to find where you did a mistake. And I'm pretty sure that this one here was the mistake. Also because this score was never appearing, and also this line here was never appearing. So this means that we were not really calling this method anywhere. And so this is here the place where the bug has to be. And now I'm pretty confident that it's gonna work. So fun. And now the current score is 1. So great. Then the same question, and it was updated to 2. So it's working. So the closure and this mechanism that we coded is working. So 1 now, so a wrong 1, and the score stays at 2. Now it's 3. Now let's put a wrong answer again. And yeah, the score stays at 3. And so everything is working properly. Exit and that's it. So take a look at this code again and try to really understand why this score function here works the way it does. We learned everything about this throughout the section, but it can be a little difficult when you actually see it in practice. So make sure that you really understand how and why all of this works. Alright, I would say challenge completed. So see you in the next lecture. Welcome to the second project of the course. This is where everything that we learned up until this point comes together, and you will even learn a ton of new JavaScript features during this project. So we're going to use all these advanced concepts about objects and functions, lots of arrays, lots of DOM manipulation, and a bunch of other important stuff. Now, this project is not just about coding. It's also about how to approach and how to solve specific problems. So basically, it's also about how to think as a JavaScript programmer. And so we'll be talking a lot about structuring our code, why we take certain decisions about objects or function creations, and so on and so forth. Because coding is not just writing a bunch of lines of code, but it's also about how to think and how to make all the pieces of a code fit together, so that in the end we have a final functioning product. So, let's finally start our big project. In this lecture, we'll take a first look at the application that we're going to build throughout the section and set up our project. So this is our budget app, and I called it Budgety here for a lack of a better name, but it serves, right? So this app allows us to add incomes and expenses for a certain month, which is in this case September 2016, and the app then calculates how much money we have made and how much we spent, and then it gives us a nice budget here in this field. So just to test it, let's add some incomes here. Let's say we have made a website project and that we made 2,500 euros or dollars, and then we hit this button and then our income appears here in this list, so the value, and then here these total income updates and the budget as well. So let's put another income, and suppose we sold our car, we didn't need it anymore, so for 1,500 euros or dollars. So this gets added to the list, and then our income gets added together. So 2,500 plus 1,500 makes $4,000 or euros. And then of course we can add expenses, so we need to change this to minus here, and then let's say we have to pay rent, so $900, and here we go. So now it's in the expense list, and this budget here got updated, so 4,000 minus 900 is 3,100, right? So this is the budget. Now let's say we went to grocery shopping, so groceries, and we spent 97.42. Okay, so commas also work in here, right? And now let's say we went on a holiday and spent $1,700. And if we make some kind of mistake or just want to remove an item here from the list, we just need to click on these icons that appear as we hover over them, right? So imagine that we didn't pay this amount after all, so we can just hit here and then it disappears and everything else gets nicely updated here. So really cool, right? And there is more. So here we see in these percentages here, the percentage that each of these expenses is of the total income. So for example, this holiday that we went on accounts for a total of 43% of our total income of $4,000. And then this 900 euros here or dollars for the rent is 23% of our income, right? And in total, we see that our expenses account for 65% of the money that we made in this month, so in September. So these are basically the features of the app that we're going to code. And I also gave this app a nice design so that the whole project gets more exciting for you. So you're going to really end up with a cool and great looking app that you can show to your friends or someone else, and not just some boring, ugly toy application. So I really put a lot of effort in this app to make it the perfect first real project for you. So you see, we have a lot of code to write to make all of this work. So let's get to work and start by setting up the project. So the starter project that you can download is already on the desktop, as always. So again, the name budgety, and then just open the project folder, and here is our project. So as in our pig game project, we have an already coded HTML file, which we will see in greater detail later as we start coding the app, and then of course a CSS file where all the styles, where all the design of the application sits. But that doesn't matter to us, because what we want is of course this app.js file, which is the file where all of our JavaScript code will go, right? So now we know how our final app looks like, how it works, and we have our project all set up. So we're ready to move on to the next lecture. See you there. Alright, so now that we are familiar with our project, we're ready to start coding, right? Well, not really. Because we cannot just start coding without having a plan of what we're gonna do. I mean, it was okay to build like the pig game project without a clear plan. But in a bigger project like this one, we really need to think about the structure, the architecture of our application. So let's do that in this lecture. So in the end, we're gonna end up with something like this. Now, is this a great piece of art or not? No, I'm just joking around. This is actually a representation of the final architecture of our app in the way that I like to display it. But not so fast. We need to think one step at a time, and we need to think together so that everything makes sense to you and so that you can think on your own when you start coding your own projects. That is really important and one of my biggest goals with this course. I want you to learn how to program and how to think, not just to copy my code. And that's also what you want, right? Okay, so let's look at our application again and identify the most fundamental parts that we need to code. And we're actually going to do this planning in more than one step. Right now, I just want to identify the most fundamental things that our app has to do, and then start coding them. And later, we're going to come back to this and then plan the rest of the app's features. So this is step 1. Alright, so we know that we can input an income or expense description and value, then hit the OK button, and then the data will appear on the user interface and the budget calculation will update. So it actually starts with a click on the button. And we already know that we can handle these kind of events using an event handler, right? So the first thing on our to-do list will be to add that event handler. Okay, and then we need to get the data out of our input fields. So we need some code for that as well. We see that this data then will be printed to the user interface. So we need to first add the new income or expense to our internal data structure, and then add them to the user interface as well. And finally, the budget is also updated. So we need to internally calculate the new budget and then again update the user interface. Does that make sense to you? Okay, so we're going to write functions and methods for all of these tasks in our application, right? So we already have a nice list of tasks that we have to complete now. But before we start coding, we also need to talk about how to structure our code. And for that, there's nothing better in JavaScript and programming in general than modules. So, modules are a vital aspect of any robust application's architecture. Also, modules help us in keeping the units of code for a project both cleanly separated and organized. And lastly, modules can allow us to encapsulate some data in privacy and expose other data publicly. All of this keeps getting more important as our applications get bigger and bigger. So basically, modules allow us to break up our code into logical parts, which are the modules, and then make them interact with one another. So what modules should we have in our project? Let's think about the tasks that we have already on our to-do list. So looking at these tasks that we specified before, we can see that some tasks have more to do with the user interface and others with doing internal data manipulation, right? So we're going to create a module for each of these so that we have cleanly separated and organized units of code in our app. So we start with a user interface module and a data module. Okay, so I would clearly say that get input values, add the new item to the user interface, and update the user interface with the new budget should all go into the UI module. Do you agree with that? Okay, and as for the data module, let's add the new item to our data structure and calculate the budget right into the data module. Now, there's still one left that doesn't really fit in any of these modules, right? So I'm going to create a new module and I'm going to call it the controller module. So in here, we'll add the event handler and specify the response to the event. The goal of this module will be to control the entire app and basically acting as a link between the other two modules. Alright, so now we have some nicely separated units of code here. And all of this will make a lot more sense to you when we actually start writing our code, which is exactly what we're going to do in the next lecture, where I'll show you how to set up these modules. So again, the planning that we did in this lecture is only for the first step of coding this project. There are a lot more functions that we're going to need in each of these modules so that we end up with a final functioning app. But we'll come back to this later. Okay, see you in the next lecture now. Let's now start to implement the modules that we talked about in the last lecture. And for that, we're going to use the extremely popular module pattern, which is one of the most popular patterns in JavaScript. And since we're now back to a big project, you'll have these what you will learn topics in the beginning of each video again, where I will list all the new things that you will learn, so you can reference these lectures later on. So in this lecture, you're going to learn what the module pattern is in JavaScript and how to implement it, and you'll learn more about private and public data, exposing methods, encapsulation, and separation of concerns, and how all of that is related to the module pattern. So this is going to be a really important lecture. But let's first remember why we're going to use modules for our project. And do you remember why? The answer is that we create modules because we want to keep pieces of code that are related to one another together inside of separate, independent, and organized units. And in each of these modules, we'll have variables and functions that are private, which means that they are only accessible inside of the module. We want that so that no other code can override our data. So our data, or code, is going to be safe, and this is really important. And beside private variables and methods, we're also going to have public methods, which means that we expose them to the public, so that other functions or modules can access and use them. And this is called data encapsulation. So data encapsulation allows us to hide the implementation details of a specific module from the outside scope, so that we only expose a public interface, which is sometimes called an API. It is extremely important to have all of this in mind when building complex applications. So how do we actually create modules in JavaScript? We use the module pattern, which is incredibly powerful, but at the same time incredibly simply to implement. All we need to know are the concepts of closures and ifs, but we already know that, right? So let's start with the module that handles our budget data, and I'm going to call it budget controller. So budget controller. And here is how we write the module with the module pattern. This variable is going to be an immediately invoked function expression that will return an object. So let's write that out. So remember, an immediately invoked function expression, or IFI, is simply an anonymous function wrapped in parentheses. So just like this. So function, and this is the function body, right? And then we just invoke the function at the end, like this, and that's it. And in here goes our code. So let's simply put a variable here for now. Let's say x is 23, and just some simple function. Let's say we want a function to add two numbers. So I'm going to call it add, simply. And our parameter is just a. And we return x plus a. So this is just a variable and a function to show you how the module pattern works. So you already know that an IFI allows us to have data privacy because it creates a new scope that is not visible from the outside scope, right? So our variable and our function, they are safe in here. They cannot be accessed from the outside. Now, the secret of the module pattern is that it returns an object containing all of the functions that we want to be public. So the functions that we want to give the outside scope access to. So let's now test this out and return an object containing a method here. So return, right? And then an empty object, and all we need to do now is to add a method. And I'm going to call it public test. And it will simply be a function that uses our other function add so that we can use it in the outside scope. So we accept the parameter b, and then we console.log the result of calling the add function with b. Okay? Let's now quickly test this in the console, right? So this time I have the browser here on the other side in full screen because we're going to need that for this application. So let's open up the console here, give it some space, and let's start by testing that we can in fact not access the x variable. So we first need to reload this, of course. So our budget controller, right? So .x, and it's undefined, of course, because as we know from the outside we do not have access to the inner scope, and also using our add function does also not work. So remember, this is our private add function. So let's now prove that we cannot use it from the outside. So let's say budget controller dot add with 5, so 5 plus x, and it doesn't work because it's not a function. So this is what we expected. And if we now go ahead and use our public test method, so public test, and now use 5, then we have a result of 28. So let's see why that is. So we pass 5 here into the function, and then this 5 value is passed into the add function, and therefore the result will be 5 plus x, which is 23, which is then 28. So using the public test method, which is the one that we exposed to the public, actually works, while using the add methods or the x variable does not, because they are private. Okay, so how does this work actually? Let's analyze what happens here. So when the JavaScript runtime hits this line here, it gets executed, and this anonymous function is declared and immediately called or invoked because of this operator here. Then these variables here and functions are declared, right? And we return an object right here. And this object contains the method that we called public test. But it could of course be lots of methods, not just this one. So this object is what gets assigned to the budget variable after this function returns. So again, after all of this runs, the budget controller variable is simply an object containing the method called public test, right? Because that's what we returned from this function here. Okay? Now we saw in our example that this public test method here then uses this add and this x variable even after this function has already executed. So why does this work and why is it so powerful? And I'm sure that you can already guess why this works. And so yeah, this works thanks to the power of closures. So remember, because of closures, an inner function has always access to the variables and parameters of its outer function even after the outer function has returned. And that's what happens here. So the iffy, the immediately invoked function expression, returns immediately, and so it's effectively gone. But the public test function that we return here will always have access to the x variable and the add function, because a closure was created here. That's why we say that the public test method is public, because it was returned and now we can use it. But the x and add variables are private, because they are in the closure, and therefore only the public test method can access them. So again, all of this works because of closures. So these functions and this x variable are in the closure, even after this iffy here has returned. So if you truly understood all the basics that we talked about before, then this pattern is actually quite simple, but still very powerful at the same time. And if you're not 100% sure that you fully understand this concept, then you can always review the lecture about closures. Alright, so the first module is created, and we now understand how the module pattern works. So let's create another module, which is the one that's going to take care of our user interface. And let's call that one the UI controller. So we talked about this module in the last lecture, right? So let's now create it. So user interface controller. So again, we write an iffy here, right? So an anonymous function wrapped in parentheses, which is then immediately executed or invoked. So here we will write some code later. And now we need our last module. Now the two modules that we created by now, they are completely independent modules. So there will not be any interaction between these two ever, because I want them to be as standalone, as independent as possible. So for example, imagine if you ever want to create a more complex budget app with a completely different user interface, you can take the budget controller module and then expand it and not think about the user interface at all. Because the user interface is separated from the data. They don't communicate at all. And that is called separation of concerns. And separation of concerns basically means that each part of the application should only be interested in doing one thing independently. So again, these two controllers don't know about each other. They are standalone. They don't even know that the other one exists. Now, we need some way to have these two connected, right? For example, we need a way to read data from the user interface and then add that data as a new expense in the budget controller. And that's why we create a third module, which is the app controller. And we also saw that one in the last lecture. So let's create that one as well. So controller simply. And now we already know how this works, right? Some space here, invoke the function, and that's it. Now, of course, modules can also receive arguments, because remember, they are just function expressions, and so we can pass arguments into them. And that's what we're going to do with this module. We'll pass the other two modules as argument to the controller, so that this controller knows about the other two and can connect them. So I will specify two parameters here. Budget controller, and I'm going to write it in a slightly different way, and I will explain why in a second. and the UI controller. So these are the parameters. And so now, when we call this function, we can pass our arguments into the function. And we want our created budget controller, so this one here, be assigned to the budget controller, which is this one here. So inside of our function here, of our controller module, it will have a different name. And the same thing with the other controller. So UI controller, okay. So I could, of course, simply have used the original controller's name inside of the app controller. Or I could even not have passed anything into the module and simply have used the other controls in here in our function, because of course we have access to them because they are in the outer scope, right? So I could simply use the, let's say, the budget controller like this in here. But that is not a good practice, because this would make the controller a little bit less independent. Because imagine that we would change the name of the module, then we would have to do this all over our code. We would have to change the name everywhere in here, right? But we don't want that. So this way, we don't have to do it. So in case we want to change the name of the budget controller to something else, we would just have to change it down here. And then inside of the module, it would always be called simply budget controller. So this controller now knows about the other two modules and it can use their code. So let's now actually try this out. So we use our budget controller and let's test the public test method and pass it again the value of 5 into it. Okay, so let's now test this. Then we store it in a variable, let's say z this time. And now, as you know, we don't have access from the outside to this variable, so we have to create another method simply to print this variable to the console. So we need to return an object once again, and I'm going to create another public method. So I'm just going to call it another public. So these names don't really matter, because all of this is just to show you how these modules work and how they interact with one another. So this is not going to receive any arguments. And now all we do is to console.log the z variable, okay? Because again, doing it like this is the only way that from the outside we can have access to z. So let's now test this. So controller, and now we use our another public method. We call it, and nothing happens. And alright, I actually know why this happened, okay? And it's because in here we don't return this value, but we console log it. And that's also the reason why this 28 appeared here in the console, because again we did console log it right here instead of returning it. Okay, so we actually want to return this result of the add function so that it can get saved in the z variable. So let's now test this again. Alright, so this time we have nothing in the console so far, and now controller dot another public. And here we go, so 28. So we have already done a lot of stuff here. We wrote different modules, both with private and public methods and variables, and we also made them interact with one another. So really cool stuff and really important concept that we learned in this lecture. So what we just created is the bare bones structure, or let's say architecture, of our application. And it's a simple one actually, but it's perfectly enough for this relatively small application. And I hope that you see how important it is to follow a good architecture, and I'm sure that you will see it even more as we progress with the course. A lot of courses will only teach you the coding part, but not the structuring and architecture that are so fundamental for this kind of project. Alright, so let's now start filling our newly created modules with some actual code right in the next lecture. Welcome back to the project. And in this lecture, we're going to set up our first event listener to handle our input button. So the new things that you're going to learn in this lecture is how to set up event listeners specifically for key press events, and you will also learn what the event object is and how to use it. But let's start by cleaning up our code here, because I want to get rid of all of this, because this was just to show you how everything works. And up here as well. So let's delete this. So some code. And I'll give it some structure here. So this is the budget controller. Give it some more space here. The UI controller. And then finally, let's say the global app controller. All right. So I'm going to set up the event listener for the input button right here in our controller, because this is the central place where I want to decide, so where I want to control what happens upon each event and then delegate these tasks to the other controllers. Okay, and we already know how to set up event listeners, right? So we first select an element and then attach it the event listener. So we use the query selector method. So document.querySelector, and you remember that one, right? And now we need to know the class or the ID name of this button. So in order to do that, let's check out our HTML file. And then I will just try to grab the class name. So we see that down here we have the button. All right. So this is the class that is attached to this button. So I'm going to copy it. And actually we should probably take a closer look at all this markup structure, but I'm going to leave that for later. Okay. So for now I'm just going to grab this class name here, but later we're going to look better at the structure of this HTML file so that we can better understand our user interface. Okay. So let's move back here and paste it here. So the add button, and this, remember, is the class selector because it is a class. And since this is how we select with CSS, remember this is then the exact same way that we select using the query selector, because it uses the same syntax as the CSS selectors. Okay, and now all we need to do is to use the add event listener method, right? And what we want is the click event, and then the function that gets executed as soon as the user clicks on the button. All right. So just to test this, let's create a console.log here. So button was clicked. And let's check this out. So reload and clicking the button. All right. So button was clicked. So it works. The event handler is properly set up. All right. So this was just a test. Now, of course, we cannot yet write the code in here, but we can write what we want to happen here later. So we can basically create a to-do list in here, which is basically the to-do list that we did in the planning lecture. So as soon as someone hits the button, we first need to get the input data, right? So get the field input data. Okay, after that, we need to add the item to the budget controller. So here we're basically creating a recipe for what we're going to do next. Then we need to add the new item to the user interface as well. We need to calculate the budget and we also need to display the budget on the user interface. All right, let's create some space here. So this is what we're going to do as soon as someone hits the button, right? So we get the input data. We then add the item to the budget controller, to the user interface, and then we calculate these budgets and display them. So over the next lectures, we're going to focus on that. But for now, there's one more thing that we need to do, because we not only want all of this here to happen when someone hits the button, but also when someone hits the return key, so the enter key. So let's see this. So imagine that someone writes something in here, let's say project, then a value here, and then instead of hitting this button here, hits the return key. So in this case, we also want all of that to happen. We also want to get the input data, we want to add the item to the user interface and to the controller and all of that. So it should be the exact same thing. So not only the click event, but also a key press event. And this is something new, so we did never use the key press event. So let's now do that. So we need another event listener here. But now we're gonna do it in a slightly different way. We're not going to select anything. We will just add this event listener to the global document, okay? So just like this, document and then add event listener. And that's because this key press event doesn't happen on any specific element, but it happens on the global web page, so on the global document, anywhere in the document, right? Now there are actually more than one type of event that handles when someone presses a key. So let's look at the event reference that I have already open here. Okay, so this is the reference for all the JavaScript events or the DOM events, and you can find this on my resources page as well. But now I already have it here open. And so here we see the keyboard events, and there are actually 3. So key down is when we start pressing the key. So any key is pressed. Then the key press event is when the key is already in the pressed position, and then the key up event is after we release the key. So for us, there's no need to use the key down or key up events. We're simply going to use the more common key press event here, okay? And remember, this is when any key is pressed, not just the enter or the return key, but this is for any key, right? So we'll need to talk about that in a second. But first, let's use the key press event here. So key press. And then again, our function. Like this, okay. Now we actually only want to execute some code when the user hits the return key, right? Not just some random key on the keyboard. So how are we going to do that? And the key to this is that this function here that is passed into the event listener can receive an argument, which is the event argument. And this is something that we have not been up until this point. So we've been using this function here, this anonymous function in this case, all the time without any parameters. But now we're going to use it for the first time, and I'm going to call it event. And actually we can use any name for this that we want, and then use it in our event listener function. But I'm just going to go with event here. Another popular name that developers use is simply E, like this, but I'm going to go with event so that we are sure what this means. So this automatically gets passed into our event handler by the browser, and there's nothing we have to do. So we just need to specify it here, and then we can use it. And just to see what this event object actually is, let's start by logging it into the console. So console.log event. And remember, this is going to happen when we press any key, so not just the return key. So take a look at the console, and I'm going to hit a button now. All right, and here we have a keyword event. So this is simply an object, as we can see, with a lot of properties. And it has a prototype, so just for the sake of curiosity, let's take a look at that. So keyword event is the prototype, and this one has also a prototype, which is an UI event. So this means that the keyword event is a UI, an user interface event. And this one is also a prototype, which is an event. And this one is also a prototype, the object. And that's it. So we know that the object is usually the last one in the prototype chain, right? So we can use all of this here with the keyboard event, right? And you know that already because of the prototype chain. But right now, I want you to focus on something else, which is this key code property here. So here you see a key code and a number, and this number is what identifies the key that we pressed. So right now I pressed a key and the key code is 107, but a different key will have another one. So let me press now another key. So I'm going to press the space key now. Actually, it has to be here in the document. So I press the space button, and this time the key code is 32. And now I'm going to press the return key. Again, it has to be here. So the enter key, and now the key code is 13. So this key code here is what we're going to use to say that we only want something to happen when this key code was pressed. So in this case, that the enter key was pressed. And in case that you ever need the key code for another key, I have this cool reference here, which you can also find on the resources pages. And in here, if we hit some button here, then we have the key code. So again, the enter key is 13, the space is 32, and this happens on any other key here. Okay, so just a cool reference. So let's now go back and use this knowledge. Okay, so what we're going to do is, as you can probably guess, an if statement. So we're going to use the event and then the key code property. And we say that it should be 13. And if it's 13, so if it's the return key, then let's log to the console that enter was pressed. Now, some older browsers, they don't use this key code property here. They use another property called which. And so it's a good practice to use that as well. And so we're simply going to use an OR operator here and say event.which 13. So if the key code is 13 or the which property is 13, then this happens. So again, this is for more older browsers or other browsers that simply don't have this key code property. And in this case, we're also safe because then we have this part here. So let's now test this. So I'm refreshing, and now I'm hitting some random keys here, as you can hear probably, and nothing happens in the console, right? And now I'm going to hit the enter key. Okay, enter was pressed. So this works. Now, what do we want to happen here? Because we don't want a console log, of course, but we want something to happen, which is, as you can guess, the exact same thing what we want to happen when someone hits the input button. So we could copy this code that we're later gonna write here and paste it here. But as you probably know, this doesn't make any sense at all, because that would completely disrespect the don't repeat yourself principle. So the solution is once again to write a custom function. So let's do that up here. And I'm going to call this one the control add item function. So var control add item. And I'm going to prepend this control here to this function name because there may be functions with similar names in the other controllers, and I want to be able to distinguish them. So I'm already planning with that, okay? So a function which simply will do all of this here. So this is not real code, of course, but this will then be where we specify all of these actions. So now what we do in here is to simply call this function. So in case that someone hits the return key, we want to call the control add item function. And that's it. And now here the same thing. So I'm going to remove this from here. So we no longer want the anonymous function here, but we actually want to pass the control add item function in here. And we already did that before actually in our other project. So it doesn't have to be an anonymous function. we can simply pass a function that we have, a standalone function, pass it here into the addEventListener method. And again, we're not going to call it here, so we don't need this call operator because this is a callback. And so the addEventListener method will call it for us when needed, so when necessary, so when someone clicks the button. So just to finally test this, let's log something to the console here. Doesn't matter here, so it works. And alright. So I'm going to hit the space key, nothing happens, and now the return key. So it works. And now I'm going to hit this key here, sorry, this button here, and so it should appear again. And yes, here it is. So it works. Alright, so now we're all set up to start adding some code to our event listeners. So let's do that in the next lecture. In this lecture, we are going to read the income or expense data out of the user interface input fields, so that we can use it in our app later. So it only makes sense that in this lecture you're going to learn how to read data from different HTML input types. Okay, so here we are in the app controller, and the logic in this project will always be that in the controller is the place where we tell the other modules what to do. So we write methods in the UI controller and in the budget controller to get some data for us or to calculate something, and then in here in the controller we call these methods. So in this particular case, that I want to get the input from the user interface, I'm going to write a method in the user interface controller and then call it here in the controller so that I can get this data and then use it further. For example, to pass it into the other controller so that it can then add the input data as a new expense or a new income to the data structure that we're going to create later. So let's now start by writing a method into the UI controller to get our input. So here in the UI controller, we're going to write a method or a function. Now, this is a function that we want to use in the other controller, right? So it cannot be a private function, right? So instead, it's going to be a public function or a public method. So it will have to be in the object that this function here, this iffy, will return. So again, and I'm sure that you remember this code here will execute immediately, and then the object that we return will be assigned to this UI controller here. And all the variables and the functions that we define in the function will stay in the closure even after this function returns. The object that's going to be returned from this will have access to these private methods or functions and variables. Alright, so let's write our method. So return, as we were saying, right? And we return this object. So let's say get input. So a function without any parameters. And now in here we read the data from the user interface. So what do we have in the UI? So we have the type here. So if it's an income or an expense, then we have the description and the value. So let's see that in the HTML file. And let's actually now take a deeper look at this file as I promised you before. So basically the UI is divided in two parts, which is the top part here, which is this one. All of this is the top part, and then all of this here is the bottom part, okay? So we have the top part, and in here we have, of course, the budget title, the month, which we're going to replace later. Then we have the budget value here. We have the budget value of the income only, and also of the expenses. So all of these are in the top part, and we're going to use all of these later on, right? And then we have the bottom here. And in here we have the add container, so which is basically our form, so where we have all our input. And then our inputs are the add type, which is for the income or expenses type. We have the add description and the add value. and the add button that we already used to set up the event handler. Okay, and then below that, the container. So basically all of this here, right? This part here of the user interface is the container, which is also divided in two parts. It has an income part on the left side and an expenses part on the right side. And each of this has, of course, a title, right? And then it has a list, so an income list, and down here an expenses list. Okay? So right now these are empty because all of the items are commented out here so that it's empty in the beginning. But this is how an item looks like. So this block of code here is an item, and we will take a closer look at this one once we start adding items to our user interface. So let's now concentrate on what we need for this step, which is this add type, add description, and add value. So value, description, and type. So we're going to select all of them and retrieve their value. So let's start with the type. And we already did this in our other project, right? So the logic is always the same. We select something and then we do something with the selection. So document.querySelector, and then remember it was the class called add and type. And actually it has 2 underscores, I think, but let's just double check. Yes, so 2 underscores, which is a special notation. Okay, and then simply use the value property. Remember that one? So that's actually it. So with this, we read the value of the type. And since this is a select element in the HTML, it works a bit different. So in these normal input elements, like this one here, so like these, we simply get the value that's written here, right? But in the select element, which is this one here, what we get is these values that are specified. So if the first one is selected, what we get is inc, which stands for income, and if the second one with the minus is selected, then what we get is the exp, so expenses. So let's just annotate this here so that we don't forget it. So will be either inc or exp for expense. All right, and now the description. So document.querySelector, and this one is add description. And again we use the value. And now finally the value. So document query selector add value, and reading the property called value. All right. Okay, so now we have the 3 input values stored in these 3 variables. Now remember, the controller is going to call this method and it wants to receive back all of these values. So we have to return something here, right? So how do we return 3 values at the same time? The best solution for this is to simply return an object containing these 3 as properties. So instead of having 3 separate variables, we should simply return an object with 3 properties, which are these 3. So let's do that. So I'm saying return an object. And so let me copy this in the inside. Now of course I need to change some stuff. So we don't need these var keywords. And it's not the equal operator, but this is how we define properties, right? Oh, and also these should be commas and not semicolons. Okay. So this is our method for returning all of the 3 inputs that we have in the user interface. So let's now call this method from our controller, and we're going to do it right here. So under this comment here, we will say var input should be the result of calling the getInput method. So, and it's a method of the UI controller, right? So UI controller, which is the module that we have access to, and then getInput, which is the public method that we can access. And no parameters here. So let's not console log simply the input. And we can remove this console log from down here. Okay. So remember, this will happen as soon as we either click the input button or hit the enter key, because this is in the function, right? So this is in a function that is called when either one of these actions happen, right? So let's now test this. And I'm going to refresh it. So let's say it's a minus, so an expense, and I'm just calling it test and some number. And now I hit enter and okay. So we have an object actually, and it has type expense. So this is correct because I chose the minus here. Then the description is test, right, which we have here, and the value is 23. So everything is correct. Let's just create another one. So test2 with something else, let's say 12. And now hitting the key. So it also works. So income and test2 and 12. Cool. So now we have these two modules talking to one another by calling each other's methods. So this is a pattern that we will see a lot of time happening. So basically the controller calling some method, and these methods then do something and return it. Now if we move up here to this method here and to this controller, there is actually one small problem that I don't like so much. And that is that we're starting to have all these strings here for query selectors all over the place. Like this one, this one, this one, and down here is also this one. And they are only going to get more as we proceed with our application. And that's a problem because imagine that we make some changes in the UI and the class names, and then we would have to change all of these strings manually. And this, of course, could cause some serious bugs. So instead, we can simply create an object where we store all of this data. And since we're talking about the UI here, we should, of course, do it in the UI controller. So we can create a private variable here and call it DOM strings. So DOM strings. And it's going to be an object. And I will store all of the strings in here. So let's say input type. And then I put this one here. And now I could go ahead and simply write DOM strings dot input type. All right. So now if I decide to change all of the class names in the entire user interface, then it's not such a big problem. Then I just have to come here and change the string in here as well, and not in our entire code. So this means that we have now a central place where all the strings are nicely stored, and we can then retrieve them and change them easily. So once again, programming is not just to make things work in some way, but it's also create the necessary structures to make our life easier. And this is definitely one of these moments where we have to create some kind of data structure to make it easier for us later on. Okay, so input description. And of course, it's going to be this one. And then the input value. And now I just need to put them back here. So DOM strings, and this was the input description. So input description, and then here the DOM strings dot input value. So just to confirm, let's reload this and see if it still works. So test 78, and yep, so it still works. All right, so Now there's only one place left where we have a hard-coded string, which is in here. Now the DOM_strings object is in a different controller, right? So we don't really have access to it from here. So is the solution just to copy this object here into our controller? No, of course not, and you already know that by now, right? So the best solution is, of course, to pass this object from one controller, from one module to the other. So what I'm going to do is something similar to the getInput method here, and this one will simply be called get the DOM_strings. And all we need in this function, in this method here, is to return our private DOM_strings into the public. So basically we're now exposing the DOM_strings object into the public. So I can now come down here into our controller and define a new variable to get the DOM_strings. So UI controller dot get DOM_strings. And that's it. So now inside of this DOM variable we also have the DOM_strings that we have up here in this controller. Because once again we expose them to the public by using this method here. Okay? So now what I can do is, of course, I first need to add this to the DOM_strings, right? So I say input button. Okay. And so now I can use it here. So DOM dot input button. Because remember, now it's called DOM here because that's the variable where it's stored now and no longer DOM_strings. So in this controller it's called DOM. So let's test this again very quickly. So again, test. Then let's say 55 here. And now I hit this button. And yes, so down here it is. So we're making some great progress here in our application. And we're getting a really nice structure here, which is something really important, as you know by now. And so in the next lecture, let's continue with that. So see you then. In order to make our app structure even a little bit better, let's now create an init function such as we did with our pig game project before. So in this lecture, you're going to learn how and why we should create an initialization function in our current architecture. So here is our controller again, and I feel like things are all a bit scattered here in the controller, like these event listeners here are just hanging around here, and then up here we have this variable declaration. And so I think we should organize this a bit and make it so that we only have functions here in the controller. So let's create a function here called setup event listeners. Okay, so a function in which all our event listeners will be placed. Because right now we have 2, but over the course of this project we will probably add some more. So let's do that. So setup event listeners. So function, and we don't need any parameters. And so I'm just going to copy these event listeners right here into our function. We don't need this extra space here. Okay, so here I left out a semicolon. And now this can go. And also into our function should of course go this here, right? Because we'll only need these DOM elements here for our event listeners. Okay, so now we have a function that sets up all our event listeners, and we have a function that gets called when we want to add a new item. And these are both private functions, right? They're not exposed to the public. Now, if we want these event listeners here to be added or to be set up, then these lines of code here, of course, need to run, right? which means that this function, this setup event listener function, has to be called somehow. And up until this point, this wasn't a problem because all of this was here in this iffy, so in this immediately evoked function expression, meaning that we didn't have to think about if this code is executed or not, because it's automatically executed, right? But now we need to call this function. And the best and most common way to do this is to create a public initialization function, which we're going to call init. So let's now do that. So since we want it to be public, we need to return it in an object, right? And we simply call it init. All right. So in this function, we can, for example, say that the application has started with a simple console log, just to test this. And then we need to call our setup event listeners function, which was why we created this init function in the first place, right? So setup event listeners. Okay, so that's it for now. This init function will be useful for other things in the future, so that's also a reason why we created this. But for now, this is enough here. So this means that our event listeners are only going to be set up as soon as we call the init function. So we need to do that, and we do that outside of the controllers. So this will be the only line of code that's going to be placed on the outside. So controller.init. And without this line of code, nothing is ever going to happen. And that's because there will be no event listeners, right? And without event listeners, we cannot input data, and without data, there is no application. So let's check out if this works. All right, so application has started. Let's see if this still works. Yes, so we still see our object here, which we still print to the console. And we can actually now go ahead and delete that console.log, if I could find it at least. Here it is. Okay, so yeah, this is our init function. We created it because we want to have a place where we can put all the code that we want to be executed right at the beginning when our application starts. And right now, that is to set up the event listeners, but there will be more code in the future. So more things that we have to do right at the start of our app. All right, that's it for this lecture. So let's now move on and create some function constructors. In this lecture, we're going to think together about how we want to store our income and expense data in the budget controller. So in this lecture, you'll learn how to choose function constructors that meet our application needs and how to set up a proper data structure for our budget controller. So let's go to our budget controller up here, which is still empty at this point. Okay, so we need a data model for expenses and incomes here. So we know that each new item will have a description and a value, right? And we also know that we should probably have some way to distinguish between different incomes or expenses. And so basically we want them to have a unique ID number as well. Now, how would you store this kind of data? I know that I would choose an object. That sounds like the best choice. So an object that simply has a description, a value, and an ID. Now, what do we do when we want to create lots of objects? Yes, we create function constructors, which we can then use to instantiate lots of objects, lots of expense and income objects. And like that, we basically create a custom data type for incomes and one for expenses. So let's do that. So I'm going to start with the expense. So expense, and you already know that for a function constructor, we usually use the capital letter here in the beginning so that we can distinguish them from the other functions. So function, and now we pass the data into it that we want them to have. So again, they should have an ID, a description, and a value. And I hope that you remember how we actually write these function constructors, right? So it goes like this. We say this dot ID should be equal to the ID that we pass in. And the same for the others. So description should be the description that we pass in. And then the value. So this dot value should be the value that we pass into our function constructor. And that's it actually. So again, we choose to create objects here through the expense function constructor because there will be lots of expenses. And therefore this is the best way to do this. Okay, so that's the expense. Now I also need this for the income. And actually it will be exactly the same for now. So I will just copy it and then change it here to income. It cannot be the exact same though, because later in the project I will have to add more things into the expense, so the expense will be different from the income. So we have to keep them separate. Now in case that we need some methods for them, we can of course put these methods in a prototype property of the expense or of the income for function constructors here, like we did before. So that all objects created through them will inherit these methods. So instead of writing these methods right into the constructors, we can put them into the prototypes. And we already learned that before, right? So this is better because in this way, they are not attached to each individual object, but instead each object will then inherit it from the prototype. So yeah, exactly like we learned before. But for now, let's leave it like this because we don't have any method here for now. Okay, so these are now private functions here in the budget controller module. But let me just take this one and copy it here to the outside, just so that we can experiment with it in the console, okay? So just like this, and I will delete it after, okay? So let's just go here and refresh this page. And then we hopefully have the expense here, let's see. So yes, this is our function constructor. So let's now create a new object using this, okay? So let's say var exp, and remember we now have to use the new keyword. And why is that? Do you remember? It's because this new keyword creates a new empty object and then calls the expense function and points to this keyword of that function to the new object that was created. So when we then set properties on the this keyword, we automatically set them on the new object that was created here. And that's why function constructors work. Alright, so I'm sure you remember this from the lectures that we had before, so I just wanted to remind you of that. And of course you can always go back to that if you feel like it. Alright, so the ID, let's say, is 1. The description can be again test, and let's say 100. Alright, and if we now see the expense object, it is indeed as we wanted it to be. So description, ID, and value, and then the prototype is of course the object. And here we see that this is an expense object now, because it was created through the expense function constructor. Okay, so this function constructor works as expected. So I don't need this anymore here, because I really just want them to be private in here. So that's it about function constructors. Let's now think about the data structure of this budget controller itself. And remember, the budget controller keeps track of all the incomes and expenses, and also of the budget itself, and later also the percentages. And so we need a good data structure for that. So imagine that the user would input 10 incomes. So we would create 10 income objects, right? So where would you store all of these 10 incomes? I think that the best solution is to store these into an array. Very simple. So we could go ahead and create something like this. So var all expenses, and then an empty array where we are then going to store all of these. And then we could do the same thing for the incomes, right? So incomes, And then we could also say var total expenses equal 0, for example, and do the same thing for the income and for the budget and so on and so forth. Now, this is maybe not the best solution, right? Because think about this. Each time that we can somehow aggregate a lot of information into one nice data structure, we should definitely do that. It's always better to have one data structure where all of our data goes instead of having a lot of like random variables floating around, okay? So let's do that. Let's create one big structure for everything. And I'm simply going to call this one data, okay? So var data will be simply an object where I'm going to put all of this data. So what do you think of doing it like this? So I'm just going to copy this. And turn it into properties of this object, right? So what do you think of this? We can still do a little bit better, right? Because both of these are arrays which store all instances of either expenses or incomes. So what we can do here is to simply write all items, and then all items is also an object. And now we say expenses is an empty array and incomes is also an empty array. And this is better. Here, of course, it's a comma. And now the same thing for the total expenses. So instead of writing total expenses and total incomes, we can say totals simply. And then let it be an object. And then 0 for the expenses and 0 for the incomes. And we're going to use this one later. And we're later also going to add more things in here. But for now, that's enough to show you how and why we should create a data structure like this. And this will make even more sense as we progress with the project. Okay, so now we have everything set up here in our budget controller, so that in the next lecture we can actually create a new item here when someone inputs a new income or an expense into our user interface. So we have our constructors and we have this data structure here ready to receive data, so we can now move on. Let's now finally use the user input data to create a new item in our budget controller data structure. And by doing that, we'll learn how to avoid conflicts in our data structure and also how and why to pass data from one module to another. And we actually already did that, but in this lecture it will make even more sense. So let's now create a public method right here in the budget controller that's gonna allow other modules to add a new item into our data structure. So we return an object once again, which is gonna contain all of our public methods, which for now is only this one, add item. So a function with some arguments that I'm going to specify right now, and then our function body. So if someone calls this method, what do they have to tell us in order that we can create a new item? First, we would have to know the type. So if it's an income or an expense. So type, and we also need the description, right? And of course, the value of the income or of the expense. And I'm using different names here so that we have less confusion. So in this method, they have their own names. So type, des, and vol. Alright, so how would we add, for example, a new expense? We would simply do it like this. New expense, and then we need an ID. We would pass the designation and the value, right? And then we would also store this, of course, in a new variable. So let's call that one new item. And I'm going to declare it up here in the beginning of the method. So var new item. Okay. So this is in the case that we're talking about an expense. So the input here can be an expense or an income. But what exactly are we going to receive here in this type argument? For that, let's take a look at the controller again. Okay. So the input that we're going to receive here, this input variable, which will come from the UI controller, will actually contain this type, right? So let's go check out this method. So it's here, right? So one of them will be the type. And this is the type that we're later gonna pass into our addItem method. And remember, we wrote down here that it will be either inc for income or exp for expense. Okay, and since we know that this is the data that will be passed into the addItem method, we know that we can expect either inc or exp. So we can now use this knowledge here in this function. So we can say that if the type is an exp, so an expense, then this is what we're going to do. So the new item will be a new expense. So I was missing the equal operator here, right? But if it's not an exp, so if it's an income, so an inc, then what we want is of course to create an income object. Okay, so again, if we receive this string here as the type argument, then we want to create a new expense using the designation and the value that we pass in. Or if the type is an income, then we want to create a new income object based on the income function constructor that we have, remember, up here also in this budget controller, right? And so this is how we create our new items. Now there's of course one missing piece, which is this ID, but let's leave this one for later. So for now, let me just say that ID is 0. And I'm going to change that later again. But for now, let's leave it like this. And so after we have the new item, we can then add it to our data structure. So remember, all of these new items will be stored in this data object, and inside this data object in the all items object. And in there we have two arrays called exp and inc. And now see that these names are the exact same names that we have here. So exp and inc, which is what we receive here from the type. So this is very, very useful because now we can simply do it like this. So data dot all items. And now we don't need any if or else statement to determine in which of the arrays we want to store the data. No, we can just do it like this. Type, right? And if we now say push, and I'm sure that you remember this method, we can add our new item at the end of the array. And that's it. So let's think about this again. So we have the type that is exp or inc, which comes from here. And these two designations are the exact same that we have here in our data structure. And therefore, we can use these brackets here to select the array that we want here from our all items object. So if it's exp for an expense, then this array here will be selected from the all items object. And if it's inc, then of course this array here will be selected. And then we can use the push method on it. And the push method, remember, simply adds a new element at the end of the array. Okay, so this is very simple. And now all we need to do is to return that new item as well. Because then the other module or the other function that's going to call this one can have direct access to the item that we just create. And this will be useful as you will see in a second. Now there's one thing that we left for the end, remember, and that's this ID part here. And this ID is a little bit tricky. So remember, the ID is a unique number that we want to assign to each new item that we put either in the expense or in the income arrays for the all items, right? So how can we determine, how can we specify this ID for each new item? The first thing that comes in mind would be to simply use the length of the already existing array and then add 1, right? So imagine that we had an array with 5 elements. So let's say 1, 2, 3, 4, 5. Then it would sound logical to say, okay, the next one should have an ID of 6, right? So the next ID equals 6. So this is just a comment just to show it to you. So this would be the simplest solution. Now there's a big problem with this, and that's because later on we're going to delete items from this. And so imagine that instead of this nicely sorted array here, we would have IDs like this. So for example, 1, 2, 4, 6, and 8. Something like this. If we would now go ahead and say that the next ID should be 6, then the problem would be that we would have 2 elements with ID of 6. So this is not ideal at all, right? Because each ID should only exist once. So in this case, what should the next ID be? It should be 9, right? So next ID should be 9, because that's the number that comes after the last one. So let's describe what we want and then code it. So we want the ID to be equal last ID plus 1. And how do we determine the last ID? In this case here, the last ID would be the position number 4, right? Because 0, 1, 2, 3, 4. And why is it 4? It's 4 because the length is 5, and since the array is 0 based, the last one is 5 minus 1. So based on that, let's do this. So we want to first select the last element. So data.allItems, and then of the type that we're currently using, right? And I already explained that down here, why this works this way, right? And now we want the last one. And the last one is simply the length minus 1. So again, data.allItems type length minus 1. Okay, so this looks a bit strange, right? So imagine that the type would be ink. So in this case, this would be data.allItems ink. So this one here. So we want to now select the last item. So we need this here, the brackets, with a number in it, so that we can select the last element. And the number is, as I explained before, the length of the array minus 1. And so we need to type all of this again, and then retrieve the length, and then minus 1. Okay, so now we have the very last item, but we only want the ID, right? So we retrieve the ID like this. Okay, so this is basically the last ID. So if our array would be this one, then our last ID would now be 8. And remember, the ID that we want is 9, so last ID plus 1. So this is the last ID plus 1. And here we have the ID for a new item. So this is actually already it. So let's just comment this. So create new ID, then recreate the new item based on inc or exp type, then push it into our data structure, and finally return the new element. And I actually highly encourage you to do this kind of comments whenever you can, so that later your code becomes more easily for you to understand when you didn't look at it for some time. Alright, so now this method is ready to be used. So let's do that in the controller, of course. Where else could it be, right? And we're going to do that right here in the control add function. So we already have our input. So we can now use that input to add the new item. And for that we call the addItem method on the budget controller. So budget controller addItem. And now let's remember the data structure that we returned from the getInput method here. So it was type description, and value. So an object with these three properties. So this input variable here right now has that object. So we now say input.type, then input.description, and input.value. Make sense? So our addItem method accepts three parameters, so three arguments, which are the type, description, and value. And so in here we pass the three, which come right from our input that we get from our user interface here with this method. And now remember that this addItem method returns an object, so we have to save it here. So let's call it new item here as well. So var new item. And let's actually also declare all the variables here at the top. So var input and new item. All right. So this should now be working just fine. And remember that this will not be yet displayed on the user interface, of course, but it should appear in our data structure. Now the data structure is a private variable in our module, right? So this data structure here is not visible. So when we add now something, then it will be here in our data structure, but it will not be accessible from the outside. So let's just quickly add a new method here, just so we can see it in the console, okay? So this method is going to be testing. Again, this is not for us to use in the application, but just to test this in the console, okay? So function, and all this does is to console.log our data structure, okay? And now we're ready to test this. All right, so let's add an an expense, like new car for $1,500 and hit OK. And all right, so we have a bug here on line 37. So let's check that one out. So line 37 again, and it's here in this line where we create the new ID. And let's go back. It says that it cannot read a property ID of undefined. Okay, and that makes a lot of sense because right now we don't have any item here in our data structure here, okay? So of course, here this length will be 0, and then 0 minus 1 is -1, and there's obviously no -1 in this array. And so this ID cannot exist because there is no item in the array for that. So what we have to do here is that when the array is empty, then the new ID should be 0. Okay, so let's do that. So if data.allItems and then the array with our type again. So the length of this should be greater than 0. And only in this case this will happen. Okay. And if not, then the ID should be 0. Okay. So this is for the beginning. So right now, the all items array of both income and expense both have a length of 0. So the ID will always be 0 now. But then as soon as we have some element, then the new ID will be defined based on this. So let's see if it works now. And again, an expense for a new car for $1,500. And all right. So nothing happened because we didn't write a method yet for displaying this in the user interface. But let's now use our testing method. So testing, and okay. So this is our data structure. And it has, of course, the all items object and the totals object. So exactly what we put in the data structure in the budget controller. All right, and here's the expense array. And there are actually already two. So I click twice on this button here. And here's our expense, the one that we created with the expense function constructor. So new car 1500 and the ID is 0. And let's see, the other expense is also new car 1500, but the ID is 1. Okay, so this was because I clicked twice here on the button. So we created 2 expenses. But what this shows us is that this is really working. So let's just add an income as well. So project, doesn't really matter, for 2000. Hit enter. And then let's use this again. So the totals there are of course still 0 because we don't have any code for this as yet. But now the income also has one element. And it's this income that we just added. So project with a value of 2000 and an ID of 0. And of course, our 2 expenses are also still here. So this is really working now. So all we need to do now is to actually add this new element into the user interface. So let's now do that in the next lecture. In this lecture, it's finally time to add our newly created object to the user interface. And this means that we're going to do some DOM manipulation for the first time in this project. And this means that you're going to learn a technique for adding big chunks of HTML into the DOM, how to replace parts of strings, and also how to do DOM manipulation using the insert adjacent HTML method. So it's time to go back to our user interface controller and add a new public method here, right? And I'm going to put it right here. And this one is going to be called add a list item. So add list item. So a function, as always, and a function body. And what kind of information do we need to add this new item to the list? First, we need the object itself. So let's call it object, and then the type. So if it's an income or an expense, so we already know that. So and this object is the exact same object that we created using the function constructor and then passed to our app controller in the last lecture. So let's quickly review that. So down here in the control add item function, which remember is the function that is called when someone hits the input button or hits the enter key, then we first read the input out of the fields, store it into the input variable, then using this input variable and the add item method, we create a new item and we return it and store it in this variable. So in here, in the new item variable, we now have the new object. And that's the object that we're going to pass to our add list item method. Does that make sense to you? So again, the logic here is that this method here, or this function, is like the control center of the application. So it tells the other modules what it should do, and it then gets data back that it can then use in other things, such as this input variable, for example, and this new item variable that we will use to display the object on the interface. So let's go back to the add list item method. So what are we going to do here? So this will be in 3 steps. So the first thing is to create an HTML string with some placeholder text. So create HTML string with placeholder text. And then we're going to replace the placeholder text with some actual data, which is the data that we receive from the object. And then finally, we insert the HTML into the DOM. Make sense? So let's talk about the first part, which is creating the HTML string. And for that, we need to look at our HTML file. Okay, so in here, this is how an income item looks like. So we have the description here, right? So salary in this case, then the value, which would be 2100 here. Then we also have a delete button. Okay, so this is the HTML for an income. And then down here we have the expense, which actually looks pretty similar. The only difference is that we have the item percentage class here, which we're going to talk about later. So this is one of the differences, and the other difference is that the ID for the expenses is expense 0, expense 1, and so on and so forth. And then here it's income 0, income 1, income 2, and so on and so forth. So we actually need to create different HTML strings for incomes and for expenses. So let's start with the incomes, and I will just copy all of this and paste it here into our JavaScript. Okay. Alright, so this looks a bit weird now, because the JavaScript file is of course not to write HTML. So what we're going to do now is to put this in our single quotes, like this. And now all we need to do is to remove all of these spaces here. Okay. So this is a bit boring work, but we'll have to do it. Okay. Alright, so now this is a string which contains a lot of HTML. And actually this is a good place to show you the difference between the single quotes, this one's here, and the double quotes. So inside of these single quotes we have lots of double quotes in here. So all of these, as you see here, all of these are double quotes. And so JavaScript doesn't interpret this as an end of the string, because we began the string with a single quote, and so the end of the string is a single quote as well. Now if we have put the double quotes here like this, then JavaScript would only interpret this as a string here, because then it would be the beginning of the string and here the end. And then here a new beginning and here a new end, but that's of course not what we want. So we want a single quote here. Now if all of these would be single quotes in here and not double quotes, then in the outside we would put double quotes, and then it would work as well. Alright, so let's call this one HTML. And I'm going to declare it up here. Okay, so this is the one for income. And the one for outcome will actually be pretty similar. So let's get this one as well. So this is like a template that we copy here into the JavaScript file so that we can then use it. So once again, removing all of these white spaces here. And here we go. So now put the quotes around this. And here we go. And now what I need to do is actually to create an if-else statement because of the type. So if the type is an income, so inc, then we want this to be the HTML string. Okay. And else, if the type is exp, so for expense, then it should be this HTML string. Alright, and now what we want to do is to replace the actual data that is in here with some placeholder. And that's because when we then receive our object here, right, we can then go ahead and replace these placeholders with the actual data. So let's do that. So let's replace this with something like this. So percentage ID percentage. And I use these percentage symbols here so that the placeholder text is easier to find here and that we don't override something that we don't want, okay? So in here, it's gonna be a value, right? So value. And I'm missing the description. Ah, here it is, okay. So description. And of course the same thing in here. So this is where the ID will go. This is the description. And then here the value. All right, cool. So let's now go to the next step, which is to replace the placeholder with the actual data. And in order to do that, we will use a brand new method that we have never used before, which is the replace method. So let's say I will create a new variable first, new HTML. Okay. So let's say new HTML is HTML, which is our string, and then strings have a bunch of their own methods, just like array. And since HTML is a string, we can use all the strings methods here. So we use the replace method. And what replace does is exactly what we want. It searches for a string and then replaces that string with the data that we put into the method. So let's start with the ID here. So our placeholder text goes like this, ID, and what we want to replace it with is our object dot ID. Okay? Because remember, the ID property is the one that holds, of course, the ID. And we can see that here. Okay? So these are our function constructors, and they are called ID, description, and value. So these are the three that we will have here in our addList method, and that we can use to replace our placeholder strings. So this was the first replacement. And now we can overwrite this new variable that we created. And now we will not replace the placeholder in HTML again, because it's in the new HTML variable now, where we have made this replacement here. So if we would now do HTML replace again, then this ID placeholder here would still be there. Okay, so we actually need to do it on the new HTML. Replace. And let's go with the description now. And say object.description. And now I'm just going to duplicate this. So here is value, and here is value as well. Alright, and now all we need to do is to insert this into the DOM. And that's something new that we didn't do before, so let's see how we can do that. So we first need to select some element on our web page, so from the DOM, and then we can insert our HTML next to that. And we're going to use the insert adjacent HTML method for that. So let's take a look at the reference page of that element, and it's right here. So this insert adjacent HTML method first accepts the position and then the text, so the string, the HTML that we want to insert. And there are 4 different positions in which we can insert the HTML. So imagine that this P element was the one that we selected. We can then insert before that element even begins, so we use before begin. We can insert it as a sibling after that, so after end, or we can insert it as a child of P. And then we have 2 options, which is after begin, which is basically before any content inside of the P element. So after the P element began, and then before the end. So at the end of the P element, but after all of the content that is inside of it. And that one is actually the one that we're going to use. So we're going to use before and I will show you why that is. So let's go back to our HTML file. And what we're going to do is to add the expenses into this expense list container. And in there will be a lot of child elements. So all of these expenses will be childs of the expense list container. So that's for expenses. And for incomes, it's called the income list. So in this case, the div element here has a class of income list. So we actually need these 2 and then decide which one we want to append this new HTML. So let's start with the income list. And maybe you can guess what we're going to do now. we will put a new field, a new property here in our DOM strings, okay? And I'm going to call it the income container. Income container. And then I will paste it here. Oh, sorry, I didn't copy it. So income list. Okay. And then I'm going to duplicate this line and do the same for the expenses. So expenses container will be the expenses list. So again, this is the element that we want to select if we have an income, and this is the element that we want to select if we have an expense. So let's do that here in our add list item method. So we can use this if else statement for that, right? So if it's an income, we can say that the element should be DOM strings dot income container. All right, and I still have to declare it here. So element. And now in case that it's an expense, then the element will be DOM strings dot expenses container. All right, and now we're ready to select this. So document dot query selector, and now we simply select the element. Okay, so very easy. This element will be the income list if it's an income, and the expense list if it's an expense. All right, and now it's time to use our insert adjacent HTML method. All right, and as we said, we're going to use before end. So before end, and then what we want to insert there is of course our HTML. So the string that we produced, and actually it's not HTML, it is new HTML, because that's the one that already has all our values, description and ID. So again, this before end keyword here makes it so that all of our HTML will be inserted as a child of these containers, so this income list and the expense list, but as the last child, so as the last element in the list. So if you already had like 2 or 3 items here, then the next one would be here after that, so the last one. Let's just look again at the reference. So imagine if we would use before begin, then the new element would be inserted right here, so before this income list, so not as a child, but as a sibling and before this element. And then after the end would be down here, so also as a sibling, but after this element. Okay, but enough code. Let's now see if this actually works. So again, we need to reload this. Okay. Application has started, so everything seems to work up until this point. So I'm now going to add an income. Let's say project for 1,500 euros. And nothing happened. And that makes a lot of sense, of course, because nowhere in our code we called this addListItem method, right? So before making it possible to anything appear here, of course, we need to first call this. So we do this, of course, in our control addItem function. So it's as simple as this. The UI controller addListItem, and now, as I said in the beginning, what we're going to pass in here is the new item that was created here before. Okay? So the object created through one of our function constructors. So the new item and then the type. So we're going to use input.type, right? Because that's where our type is stored. So whether it's an income or an expense. And now it should be ready to work. So again, project 1,500. Oh yeah, here it is. So it worked. It is here in our user interface. How cool is that, right? So it really worked. This is really cool. So let's try it with another one. Let's say we sold our car for 2,500. And yeah, here it is also. So for me, this is a really magical moment when we hit the enter button here and then something like magic appears here on a web page. So this is really cool. Let's try out an expense now. Let's say our rent is like, I don't know, $950. And now it should appear in the expenses, right? And yes, here it goes. So everything works exactly as expected. Now forget about this 21% here, because this is just the text that we copied from our HTML page, and we're going to take care of this later. But for now, what matters here is that at this point we're able to really add the elements to our user interface. So this is already a great achievement. So now that we have this, over the next lectures we're going to take care here of the budget part. So we're going to calculate the budget and update it here on the user interface as well. So don't wait and join me right in the next lecture. So in the last lecture I promised you that we were going to work on the budget calculation now, but first we need to actually fix a really annoying thing in our user interface, which is to clear the input fields after we entered an input. And in this lecture you're going to learn a lot of new stuff. So you'll learn how to clear HTML fields, how to use query selector all that we hadn't used before. You'll learn how to convert a list to an array, and also a better way to loop over an array than for loops. And that is the for each method. So a lot of stuff to cover in this lecture, so let's do it. So here is the problem that we need to solve. So in the last lecture we added this rent here, but now this rent and the value as well is still here. So we can continue to click here and the new one will be added. And if we continue to click, new ones will be added. So all of these rents are now here. So of course we need a way to clear these input fields, right? So let's now do that. And since this has clearly to do with the user interface, we go to our UI controller, which is right here. So we're going to add a new method to this controller. And of course it's going to be a public method once again. And this one is called clear fields. So clear fields. And of course we don't need any parameters because we already know which are the fields that we're going to clear, which are the two that we saw before. Alright, so these are two fields. So let's now use the query selector all instead of doing the query selector that we've been using. So we could do that, then we would use it twice, but instead we can reduce it to one line of code by using the query selector all. So let's do that. So document.query selector, and this time it's the query selector all. So let's check out which one we need. So it will be the input description here and the input value, right? So we need to select these two. So DOM strings dot input description here. Okay. And now remember, the syntax here is like CSS selecting. So we separate different selectors simply with a comma. So we need a string with a comma here, and then we can join these strings together, right? So what is left now is the input value. Input value. Okay, and let's actually store this in a variable. Okay, so I'm going to call it fields. So fields, because these are our two fields, right? And let's declare the variable once again here in the top. So var fields. Okay, so this fields variable now holds the result of this selection. Now the problem is that the query selector all method does return something strange. It doesn't return a nice array which we can then use and loop over, but instead it returns something similar but still different, and that's a list. So again, a list is a bit similar to an array, but it doesn't have all of these nice methods that we have for arrays. So the solution to that is to convert the list to an array. And there's actually a nice little trick that we can use for that. And the trick is to use the array method called slice. And what slice does is to return a copy of the array that it's called on. So usually we call this method on an array and it then returns another array. But we can kind of trick this method and pass a list into it, and then it will still return an array. So that's the solution for this. Alright, but there's only one small problem with that, because we cannot do it like this. So fields.slice will not work, because again it's not an array, and so we cannot call array methods here on the list. Instead, what we have to do is to call the slice methods using the call method, and then passing the fields variable into it so that it becomes the this variable, and then it's gonna work just fine. And how can we do that? So where is the slice method actually stored that we can use it? Let's think about that. So where do you think it is stored? And the solution is that it's in the array prototype. So we can write something like this. So this array is the function constructor for all arrays, right? And we know that all the methods that the arrays inherit from the array function constructors are in the array's prototype property, right? And therefore we know that the slice method must also be there. So we can write array.prototype and then .slice. Alright, so here it is. And since this is a function, we can then use the call method on it, right? So call. And then in here, we set the this variable to the field. And this will trick the slice method into thinking that we give it an array, and so it will return an array. So if we now store this into a variable and call it fields array, then this will be an array. And actually, again, I'm putting it up here. So fields array. So this is now an array. So this is a nice little trick that we can use. This means that we can now loop over this array and clear all the fields that were selected, which were only 2 in this case, but if it would be more, then all of the fields could be cleared at once. Now we could do it with the old school for loop that we have been using all the time up until this point, right? But let's make it more exciting, and so I will show you a new method that we can use on arrays, which is the for each method. It works something like this. So fields array, and now for each. And this is really simple. All we have to do is to pass a callback function into this method, and then this callback function is applied to each of the elements in the array. So let's put an anonymous function in here. Okay. Just like this. Now this callback function here, so this anonymous function in this case here, can receive up to 3 arguments. And this is really like the callback function that we saw before on the event listener. Remember that? In that case, we did automatically have access to the event object. And we could name that object as we wanted, right? So here it's actually pretty similar. So here we have access to 3 things. We have access to the current value. So this means the value of the array that is currently being processed, let's say. Then we also have the index number. So the number going from 0 to the length of the array -1. And then also the entire array. So we have access to the entire array here as well. And again, we can name this as we want. We could just call these something like cur, let's say. And this one just index or just I. So we can do it as we want, and it will always work. So this is something really nice that JavaScript has for some methods. So remember, what we want to do here is to simply clear all these fields. So we want to see them empty. And that's actually really simple. So all we have to do is to select the current, okay, which is this here. And this means the current element that is being processed. So it will first be the input description and then the input value, right? So if we set the value of these back to empty, then the fields will simply be cleared. And it really is as simple as this. So again, this for each method here loops over all of the elements of the fields array and then sets the value of all of them back to the empty string. And we have access to the current element thanks to this callback function here, which has access to these three arguments. So the current element, the current index, and the original array, which in this case would be fields array. Okay? So let's now use this method. And for that, we're going to go back to our controller. And this is something that we actually didn't put here in our comments. So let's say for clear the fields. And what we're going to do is UI controller and clear fields. So as simple as that. So let's now test this. So reload. And now salary, let's say, of 1200. And yeah, the fields are empty now. Let's try it again. So holidays, 600. And yeah, it's empty again. Now, one thing that we should also do is to set the focus back to the first field here, right? So that we can easily continue to put more items in here. And that's also pretty easy to do. So let's just go back to our clear fields method. And then we just need a line of code here, which sets the focus on the first element of the array, right? So fields array 0, which is the first element, which will be the input description, which is exactly what we want. So it will select the first element, and then we simply need to use the focus method. So focus, and that's it. All right, let's see that again. And again, salary, 1200, let's say. And yeah, the focus is back to the description. So this makes it easier to input the values. All right, but now it's really time to start working here on the budget and on the total income and expenses. So come with me right to the next lecture. In this lecture, we're going to start working on updating the budget, and the first step is to look at our controller module. We'll also fix some minor problems that our app still has at this point. And so you'll learn how to convert field inputs to numbers, and you'll also learn how to prevent false inputs. Alright, so here in our controller module, and more specifically here in the control add item function, we already have these spots here to call the methods that are going to handle the budget update. Now I want to move this to a separate function, and that's because first, these steps kind of belong together, and second, because we're going to do all of this again later when we want to delete an item. So instead of repeating this code by then, we can simply write a new function to keep the dry principle, so the don't repeat yourself principle. And so I'm going to do that right now. And I'm going to call it update budget. So very simple. So var update budget. And we don't need any parameters. So all of this will actually go in here. So first we calculate the budget, which we're going to do in the next lecture in the budget controller. And then we're also going to have a method that will then return the budget. Okay, and I'm doing two separate functions here. So one that calculates the budget and one that simply returns the budget and does nothing else. And that's because I want you to get used to this kind of philosophy that each function has a specific task, and that simply getting some information from a module is a good task for a simple function. And we actually have already done some of these get functions like get input or get DOM strings, and so we're going to continue with that here. So we will have another function in the budget controller that will simply return the budget. And then of course we need to display the budget on the user interface, and that will be a method on the UI controller that we're also going to code not in the next lecture but in the one after that. Okay, so then we have to of course call this function in here, right? So let me just say calculate and update budget, and then we call update budget. Alright, so in here we set the stage. Now we just need to code all of these methods over the next lectures, and I will then call them from the update budget function. Now, before we can move on to actually do all of these calculations, there are still two things left that we have to take care of. And in order to see them, let's look again at our project here. And the first one is this. So let's suppose we add something here. Let's say salary again, and then 1200. Okay, so everything nice here. So let's use the test method that we did for the budget controller. Remember that? So we had budget controller and then a testing method, which was only to display the internal data structure where all the incomes and expenses are stored. So here is the object, if I remember, is called data, and it has these two objects in it. So here we have the income that we just added, right? So this array, actually this object, so the description is salary and the value is 1200 and the ID is 0. Now here is the problem. We see here that this value is not really a number, it's actually a string, right? And that is a problem. So the ID here is a number, so everything's fine here, but this is a string and we cannot do calculations with strings. So we need to change this. So remember where we actually read this data from the interface? There's a method up here, and here it is. It's the get input method, right? So here in this line of code we read this value, and what we read is a string as we just saw and not a number. But fortunately there's a very handy function in JavaScript which is simply called parse float. So parse float, which converts a string to a floating number, so basically a decimal number, a number with decimals. And so we can have numbers with decimals. So instead of having $10, we can have $10.50, for example. Alright, so again, this function is going to take this string here that this returns and convert it to a number, which is then assigned to this value property. So let's now reload this and check if that actually worked. So salary once again, 1200, and then we need to use our testing method again. And now you see why it's so useful to simply write a testing method like this, not to use in production, so not to use in the final application, but here during development, it's really useful to have a public method like this to expose some internal data. So all items again, the income, and all right, here we go. You see, now it's a number, so it no longer has the quotes, and it's also here printed blue, like the 0, right? So now it's a number, and now we can use it to make calculations. And so we solved one of the two problems. So let's see the second problem, and to show it to you, all I have to do is to keep clicking on this button. So, do you see what's happening here? We are simply adding empty lines without anything in them. And that's because we don't have any test. We don't have anything in our code that says that we actually need to have some data here and some values here, right? And so this is another thing that we really need to take care of before we can move on. So let's do that now. And the best place to do this is in the function in our controller where we say what to do when the user hits the button. Okay, so let's come back down here, and this is the control add item function, right? So what we can do here is to say that we only want all of this here to happen if there actually is some data that we can use. So we can of course use an if statement for that, right? So let's put it right here. Okay. And what do we want here? First, we want the description to not be empty, right? So let's say input.description should be different from the empty string. Okay, so this will prevent that there are some inputs where there's no description at all. Now we also want the same thing with numbers, right? So there's a function in JavaScript which tests if a number is not a number. So this sounds a bit confusing, so let's go back here to the interface. Okay, so in JavaScript there's something, this NaN, and this means not a number. And so as we hit this input button here, without any number here, this then returned not a number, okay? And so what we want is that this is not a number. Make sense? So right now it's not a number. So what we want is the other thing. So we want it not to be not a number, so that it's a number. So what we can do is to test if it's not a number, like this, is not a number, and then we pass the input dot value. Okay. Now, if this is not a number, it will return true. And when it is a number, it will return false. But we want the exact opposite, right? So we can simply use the not operator here. And this way it will be true if it is a number, and it will be false if it's not a number. And now all we need is the AND operator here. So we want this to happen at the same time. The input description should not be empty, and the number should actually be a number. So it should not be not a number. So this is already pretty good, but we can do even better, because imagine the case that the input value is 0. That is also not really an expense or an income, right? But it's still a number, so it will pass this test here, right? So what we can do is to simply add input value should be greater than 0. So make sense? And now all of this only happens in case that these three conditions are all true at the same time. And that's why we use the AND operator. So this is what we want always to happen, because without this we don't have any data at all to test. But all of the other stuff, so adding the new item and to the budget controller and to the UI, clear the fields, and all of this should only happen if there is actually some significant data that we can use. So let's now test this. Okay, so if we now hit this here, nothing happens. If we add something just like this, but without the number, also nothing happens. And now let's put 12. Okay, so now it worked. Now let's test only with the number, and it does not work. So test 2, and now it should work. So I hit return. All right, and now let's add another test, test 3, with 0. So it should also not work, right? And it doesn't, so great. But 0, 1 works. So we have 1 here. So perfect. So all of the problems are solved now, and so we're ready to move on to actually do the real calculations. Let's now do the actual calculations of the total incomes, total expenses, and the budget. And so in this lecture you're going to learn how and why to create simple, reusable functions with only one purpose each, and also how to sum all elements of an array using the for each method. So let's go to work. So this is how we left the update budget function in a controller after the last lecture. So it's now time to calculate the budget here in step 1, And for that, we're going to create a public method in the budget controller, right? And so it's up here. And I'm going to call it calculate budget. So very simple. And it's a function, of course. And in here, there's a couple of things that we have to do. So I call this the calculate budget function, but in fact, we're also going to calculate first the sum of all incomes, as well as the sum of all the expenses. So the total income and the total expenses. And then of course the budget, which is one minus the other, and then also the percentage. So let's show that on the user interface. So this is the percentage that I'm talking about. And this is very simply the percentage of our income here that we have already spent, so which are expenses. So let's write all we have to do here. So calculate total income and expenses, then calculate the budget, which will of course be income minus the expenses, right? And then finally calculate the percentage of income that we spent, basically. Okay, so let's start at the beginning right here. So calculate the total income and expenses. So this sounds like we're going to do the same thing 2 times, right? Once for the income and once for the expenses. So I think this sounds like making an extra function for this, right? So a function that receives if it's either the income or the expenses that we're talking about, so that we want, and then sum all of the items. Okay, and since we don't want no one else to use this function, we can make it simply a private function. So it's just an internal function to help this calculate budget method. Okay, so I'm going to do it out here, and I'm simply going to call it calculate total. So calculate total. And then what we need to say here is simply if we want to calculate the total expenses or the total incomes. So we're again going to use our type keyword. Okay. Okay, so how are we going to do that? So we already know that all of our items are stored here in the all items object, right? And all the expenses are in this array and all the incomes are in this array, right? So at some point of our application, there are going to be a couple of objects in both this and this array here. So what we need to do is to get this array, then loop over it, and then sum all of the values. So add all of the values together. And so the first thing that we need to do is to simply create a sum variable, which will store the sum, okay, and set it to 0, because that's of course the initial value. Okay, and then we loop over this array. And do you remember a great way that we learned in one of the last lectures about looping over an array? It was the for each method, right? So let's get our array and use the for each method on it. So data, which is where all of this is stored, then the all items object, okay, and then, such as we did before, we use our type argument to select if you want to expense array or the income array, right? So this type here will of course be either exp or either inc, such as we've been using before. Alright, so this is the array, and now we can use the for each method. And remember, this accepts a callback function, okay? So function, and then this function here has access to a couple of parameters. Remember that? So we can access the current value, the current index, and also the complete array. In this case, we only need the current element, okay? So I'm going to call it cur simply. And remember, we can do that. We can call it whatever we want. And so now I say that the sum should be equal to the previous sum plus the current value. And so it's cur.value. and it's cur.value because value is the name that we gave it here, right? So in the expense and in the income, they both have this property called value, which is where we store the value. And so this cur here now refers to either the income or the expense object that is stored at the current position of the expense or the income array, okay? Okay, just to illustrate this, let me just write a simple example here, okay? Just so this makes more sense to you. So the initial sum is 0, right? And imagine we have an array which has these sums, so 200, 400, and 100, for example, okay? So in the beginning, our sum is 0. So in the first iteration, our sum is 0. And so the sum will be 0 plus 200, because it's the first element of the array, the first value in this case. So notice that these are only values. This is just an example to see you how this iteration works and how we calculate the final sum. So in the next iteration, then our sum is already 200, right? And so now sum is equal to 200 plus the 400 from the next element. So this is 600. And so in the next loop, in the next iteration, it will be 600 plus 100. So 700 in the end. All right, so this is how this loop works. Now we can do this better, right? Remember, there's this operator where we can put a plus here, and then we don't need this. So this is a bit simpler. And so after this loop, we have our sum stored here in this value. And what are we going to do with this then? We could return it, but I think it's even better to store it in our global data structure. So in our global data model, which we have here, okay, so this data object, which contains all of our information. And so in here, we before already put this totals object. So now we can use this and store our sums in here, right? So let's do that. Data.totals. And then again, we use our type, because once again, there's expenses and income. And then we simply say that this should be equal to the sum that we just calculated. And that's it. So this function is completed now. So let's use it here in practice. So we're going to go back to our calculate budget method. And so now I can call our private function. So I just say calculate total, and here it is. And I first do it with the expenses, and then I do it with the income. And that's it. So after running these two lines, or a data structure here has these two values here filled, so they are not 0 anymore. So they are now set to the total expense and the total incomes. Okay, and now we just need to calculate the budget. And where do you think I should store this budget? Exactly. Once again, we are going to use our global data structure that we have here. So we're going to create a variable in here called budget and set it initially to 0, okay? And now we can go ahead and fill this value here with our budget that we're going to calculate. So we say data.budget will be equal to the income minus the expenses. And remember where these values are stored? Exactly, they're also in the data structure. So data, and now remember they're in the totals dot income. And now minus data.totals dot expenses. Okay, so this retrieves these two values here from our data structure, then calculates one minus the other, and then stores it again in the data structure in the budget property. And now the final task of this method is to calculate the percentage of income that we spent. So once again, let's create a new property here and simply call this one percentage, and also set it to 0 in the beginning. Or actually, let's set it to -1, because -1 is usually a value that we use to say that something is non-existent. So if there are no budget values and no total expenses and incomes, then there cannot be a percentage. So we set it not to 0 but to -1, so it doesn't exist at this point. And so now we can store the percentage that we calculate also in the data structure. So data.percentage. So the percentage of income that we spent is the expenses divided by the incomes, okay? So data totals expenses divided by data totals dot income. Okay, so just an example, let's see. Imagine we have an expense of 100 and an income of 200. Then we spend 50% of our income, right? So this is equal to 100 divided to 200, right? And this is actually 0.5, so we have to multiply it by 100. So let's do that here as well. So I'm going to put some parentheses here, which are actually not necessary. But this way it looks a bit better, a bit more structured. Now the thing is that this will have a decimals. So imagine it would be here, instead of 100, it would be 300. Then we would have spent 33.333 and so on. So this would be 0.3333. But we don't want that. We really just want this integer part here. So let's also round this result. And we already did that before. So remember, we used the math object. And in here, there's a nice method called round. And so this will round whatever we input here to the closest integer. Okay, and with this, we calculate our percentage. So we have now everything that we wanted this method to do. So we have our total income and expense, we have our budget, and our percentage. So let's now use this method in our global app controller. So this is down here, so calculate the budget. So we say budget controller, as you already know, and then our newly created method, which is calculate budget. Alright, so this calculates the budget. And now we need a method which returns the budget to us so that we can store it here in a variable and then pass it on to the user interface controller, which is then going to display it here in this third point. So let's do that very quickly. So again, in our budget controller, we need a new method, and this is going to be called getBudget. And again, I'm doing it like this. I'm creating a method only for returning something from our data structure or from our module, so that you get used to this whole philosophy of having functions that only retrieve data or functions that only set data. So let's write this very simple method here. And again, budget returns not only to the budget itself, but also to the total incomes and expenses and the percentage as well. So we want to return these 4 values. And what's the best way to return 4 or even more values at the same time? Exactly, we're going to use an object. So we simply do it like this. Return this object. And in here, we now create the 4 properties for the 4 values. So budget will be data.budget, right? Because remember, that is the place where we store the result of that calculation. Okay? Then we want the total income. So just like this. And this is stored also in the data structure, in the totals, and then in the inc property. Now the same for the expenses. And finally, we also want the percentage, of course. And that's it. That's all that this function, that this method here has to do. So let's now use it here. And this time we return something, so we have to store it in a variable, of course. So let's simply call it budget, okay? So var budget is the result of calling budget controller dot get budget. And that's it. So now we should have the budget stored here in this variable. So we are ready to display it in the user interface, but I'm going to leave that to the next lecture. So right now I just want to console log this object so that we can see if everything we did before is working, okay? So budget here. And remember, this whole update budget function is called each time we enter a new item into the user interface, right? So let me see. So it comes from here. Okay. So the control add item function is called each time that we input a new element. Okay, so this calls the update budget function, which is this one, which then in turn calls all of these methods here. So the calculate budget and get budget methods. So this console.log here will appear in the console each time we input a new item. So let's now test this. So let's say project and okay. So down here we have our budget object, okay? And let's take a look at it. So the total expenses are 0, the total income is 2100, and the budget is of course 2100, and there's no percentage. So everything seems to be working, right? Let's just add another one. So I sold my car again for $1,500. And so let's see the budget now. So this is the sum of 2100 plus 1500, and this makes 3600. And the budget is also 3600 because we don't have any expenses yet. So let's say we went on a holiday, which was $1,800. And now here we are. Oh, actually I did this wrong. I put it in as another holiday, as another income. So I have to change this, of course. So let's now say holiday for 3600. That's because I want to show you the exact percentage. Okay, so now this seems to be working. So the budget is 1800 because it's 5400 minus 3600. Yeah, makes sense. And then the percentage is 67. And that's because, let's calculate it here, 3600 divided by 5400 is this number here. And if we multiply this by 100, then it gives us 67% if we round this, okay? So this is actually working. So there's only one thing to correct, and let me just reload this for that. Imagine that we only have expenses, okay? So let's say again, holiday for $900, and now we have this problem here. The percentage gives us this weird infinity value. So infinity. And that's because we cannot divide anything by 0, which is what we attempted to do here. So we did 900 divided by 0 because we don't have any income yet. And that is not allowed in mathematics. And so we have to fix that in our code. So let's go back to the method where we calculate this, and it's right here. So what we have to say is that we only want this calculation when we already have some income. So when the total income is greater than 0. So let's use an if statement. So if the data totals income is greater than 0, then we want this to happen, okay? And if it's not, then we simply want the data percentage to be -1, which, as I explained before, is basically the non-existence. So when there's no percentage to calculate, we just say it's -1, and we'll use that -1 later when we display this percentage on the user interface, okay? So let's now very quickly test this again. So add an expense, holiday for $900, and now here it is. So now our percentage is -1, and everything else is also working. So the total budget is negative, of course, because 0 minus 900 is minus 900. So the next step is, of course, to add this budget here to our user interface right here in this field. So here, and here, and here, and here. So let's do that right in the next lecture. Now comes the fun part, where we'll finally see the budget updating on the user interface. And since this will be a shorter lecture, we will just practice some more DOM manipulation by updating the budget and total values in the user interface. So of course we need to add a new method here to our user interface controller, right? And let's call it display budget. And let's put it here. So display budget. And what do we need here in order to be able to actually print the budget? Of course, we need the object where all of this data is stored. So I'm going to call it obj, just like we did before. And this will then contain the 4 pieces of data that we want to print here, right? So the budget, the total income, the total expense, and also the percentage. So we're going to do some more DOM manipulation. And in order to do that, we need to know the class names of the elements on our user interface that we want, right? And so once again, we're going to add some more strings here to our DOM strings object so that we can use them then in our methods. So let's go to our HTML file where our user interface is stored, right? And so this is here in the top part, as I showed you right in the beginning. So the actual budget value, which will be stored here, so right here, this will be called budget value. So let me copy this and then paste it here. And I'm going to call it budget label, because these basically act as labels in the user interface, okay? So the class selector and then the class name. All right, so next one. So now we need our total income, which is here, right? And the total expenses is down here in this div element. So let's just check. So it's this here and this. So these are called budget income value and budget expenses value down here. So let's add these two as well. So let me call this income label. And actually I didn't copy it. Okay. So now it's here. And now the expense label. So income and expenses. And finally the percentage as well. So let me check that as well. And it's here. So this is called budget expenses percentage. And copied this as well. And now percentage label. And now we're ready to use this. So remember, we store all of these class names here in this central object that we have here, so that we don't have all of these class names here floating around in all of these methods, okay? And so if something changes in the user interface, we can simply come here and update all of these class names if we want. So this makes our lives as programmers much easier, having this kind of structures. Okay, now we already know how to display all of these values on our web page, right? So we have done this a lot of time. So we use document.query selector and then DOM strings dot budget label, which is the first one. And then in this case, we don't want to change the HTML, but only the text content. So we say text content, okay? And now this should be equal to the budget. And this budget comes here from the object that we passed into this method. So object dot budget. And that's it. And now I'm just going to duplicate this line because we already know how to do this, right? So now I just need to replace a couple of things here to make it work. So the income label, right? And now we need to know the name of the property where the total income is actually stored. So let's go back to where we generate this object. So remember, it's here in the getBudget method. So this is where we create the object that's going to be returned to the app controller, which then passes it into the displayBudget method that we're working on right now. Let me just copy this so that I have the names here. Okay. So this one is called Total Inc. Total Inc. And here is the expenses label, right? And this one is called, as we see, Total Exp. We're just going to copy it. And then here, this one is called percentage label. And this should be percentage label. Let me change it in both places. Okay. And now this one is simply called percentage. So I'm copy and paste. And now before we can see this in action, we need to, of course, call this method here, right? And also add this comma. Okay, so displayBudget is the method that we're going to call. Oh yeah, it's here. So before we had this console log here, which we don't need anymore. And so now we use the UI controller to call the displayBudget method. And now what we have to pass in here is the object that we called budget, right? So this object here, which is, as I showed you a couple of moments ago, the object that is returned from the getBudget method. Okay, and now we're ready to check this out. So project 1500 and all right, it works. So the budget is 1500, our income is 1500, and our expenses are 0. Let's now add another one, salary, let's say 2500, and now it should be 4000, right? So let's see. And yes, it is. So it updated very nicely here. And now I'm going to add an expense as well. And I'm going to call it holiday again for 1200. And it works. So we see 1200 here, then our budget, which is now 2800, and then the percentage here is also correct. So with this holiday here, we now know that we spent 30% of the money that we made in this month. Now we don't only want this to be 30 here, right? So let's add the percentage sign here. And actually there's another thing that we have to do. So let's reload this. And that's simply add an income. So now we have -1%. And we don't want the user to see -1%, right? Because that doesn't make any sense at all. So we need to be prepared for this case and display something else there. So let's do this. So back to the displayBudget method here. We basically need an if-else statement here, right? So we say if there is a percentage, so if it's not -1, then we want to add the percentage sign. So if it's 30, we want to display 30%. But if it's -1, we simply want to display something else. So let's say if object percentage is greater than 0, then we want this to happen here. Let me cut this from here and paste it here. So we want this object percentage plus the percentage sign, right? But if it's not, we want something else. So we don't want to see the percentage value here, but we want to see something that shows us that there is nothing to show actually. So let's put simply some of these dashes. So this shows that it's empty. And notice that this is not only going to happen when the percentage is -1, but also when it's 0, right? Because in here we said greater than 0. So this only happens, so this percentage is only shown if the percentage is greater than 0 and not if it's greater or equal. But that's totally okay. So let's see that in action. So I'm going to add a holiday for 1200. And yeah, now we have these 3 dashes that we had before. Cool, right? Let's now add a salary for us of 2,400. And now we see that we spend 50%. So now it's working really good. Only one small thing that we can improve now is, you see when we reload this, then we have these weird numbers here that we obviously don't want, right? So remember, there's something that runs each time that our application starts. And do you remember what that is? Yes, it is the init function. So we can not only call this method that we just created each time that we input a new item, but we can call it right in the beginning when we start to run our application. So let's copy this. And then say that we want to run this right in the beginning. Now the thing is that we don't want to pass the budget in here, right? Because what we want is basically to reset everything. So we want everything to be set to 0. So what we need to pass here is actually an object similar to the budget object, but with everything set to 0. So let's just grab this object from up here, okay? And put everything to 0. So very simple. So back to our init function, okay, here. Let's pass this object, but we set everything to 0. So the budget is 0, the total income is 0, the total expense is 0, and the percentage is not 0, but -1. So there's no percentage at all. So let's check this now. So when we reload, everything should be set to 0, right? And yes, here it is. So no budget, no income, no expenses, and no percentage to show. Okay, and with this, we have actually finished everything that we had planned for the first step of building this application. And it already looks pretty cool, right? So great work so far. So we can now already do a lot of stuff with this. But there are actually still a lot of more cool features coming up over the next lectures. So with the last lecture, we completed the first step of our app. Congratulations for that. You have come a really long way. So let's now take a look at the structure of the app that we have built so far, so that we can then outline what to do next. Alright, so this is how I like to represent the structure and architecture of an app like the one that we're building right now. So we have our 3 modules. So the budget controller, the app controller, and the UI controller. And in each one of them, we can see the functions or methods that we have written so far. And then with these green arrows, we see the connections between them, so that we can see functions calling other functions. So this really helps us to get a nice overview of what we're doing here, right? So it really makes it easier to plan and organize our app and code. For example, we can see the effect that a simple click on our input button has, which is this green dot here that represents an event. And there will be more of them in the future. So as we know from our code, clicking this button will call the control add item function, which will then call all of the other functions and methods that we see here connected with the green arrows. So again, this gives us a very nice high-level overview of our app. And I really advise you that you always draw up something like this for your own apps or whatever you're gonna do with JavaScript. Let's now continue with the planning and see what we can do in step 2 of building our app. So far, we can input data into our app, which is then stored in a data structure and displayed on the user interface. What's missing here is the functionality of deleting an item from this list. So let's take care of that now. So we already have our delete buttons in the UI, but they are not doing any work yet, right? So once more, we start by adding an event handler to them. We then go ahead and delete this entire row as soon as the user clicks the button, both from our data structure and from the UI. And after that, of course, we also need to recalculate the budget and update it here on the user interface. Alright, so we have a nice little to-do list here again, so let's get back to work right now. Before we can start implementing our code to delete items from our application, we need to talk about something called event delegation, which is a very important and much used concept in JavaScript programming when we interact with a DOM. Alright, so in order to talk about event delegation, the first concept that we actually need to talk about is event bubbling. And event bubbling means that when an event is fired or triggered on some DOM element, for example by clicking on our button here on the right side, then the exact same event is also triggered on all of the parent elements. So again, the event is first fired on the button, but then it will also be fired on all the parent elements, one at a time. So it will also fire on the paragraph, the section, the main element, and actually all the way up in the DOM tree until the HTML element, which is the root. So we say that the event bubbles up inside the DOM tree, and that's why it's called bubbling. Now, the element on which the event was actually first fired, so the element that caused the event to happen, is called the target element. And so in our example here, it's of course the button that was clicked. The important part is that this target element is stored as a property in the event object. And we already talked about that one, right? So this means that all the parent elements on which the event will also fire will know the target element of the event, so where the event was first fired. And that brings us to event delegation. Because if the event bubbles up in the DOM tree, and if we know where the event was fired, then we can simply attach an event handler to a parent element and wait for the event to bubble up. And we can then do whatever we intended to do with our target element. And this technique is called event delegation. In this example here, we could simply add the event handler to the main element. Alright, so again, event delegation is to not set up the event handler on the original element that we're interested in, but to attach it to a parent element and basically catch the event there, because it bubbles up. And we can then act on the element that we're interested in using the target element property. And why would we actually want to do this? So let's see. There are basically two big use cases for event delegation. And the first case is when we have an element with lots of child elements that we are interested in. In this case, instead of adding an event handler to all of these child elements, we simply add it to the parent element and then determine on which child element the event was fired. And the second use case for event delegation is when we want an event handler attached to an element that is not yet in the DOM when our page is loaded. And that's of course because we cannot add an event handler to something that's not on our page. So in the case of the application that we're coding, it's actually both cases, right? So we have a lot of expense or income items that are not in the DOM when we load our page, so there's no way to attach an event handler to them. And also, there may be a lot of items, so it wouldn't be useful to have one event handler attached to each of them. And that's why we're going to use event delegation. So let's see it in practice in the next lecture. Alright, now that we know about event delegation, we're finally going to start implementing the code to delete income or expense items from the app. And so in this lecture, you're going to learn how to use event delegation in practice using the concepts of event bubbling and target element. And you're also going to learn how to use unique IDs in HTML to connect the user interface with the data model, and how to use the parent node property for DOM traversing. Alright, so we're going to start by adding an event handler here. And we do that here in our setup event listeners function, right? And remember that we're going to do event delegation. So we're going to set up the event on a parent element of the elements that we're actually interested in. So let's first check out our HTML file so that we can decide where to add or to attach our event listener. So first of all, we want our items to be deleted when the user hits on this button here, okay? So this button called item delete button. And there's one of these buttons in each and every income and also expense elements here. But again, we don't want to attach our event handler to these because we want to do event delegation. So we want to find an element that is the parent of all of these items, both the incomes and all of the expenses. And if we look closely at our HTML document structure here, we see that the first element that satisfies this condition is this one here. So this one called container. So it has the container class. And that's because all the incomes are inside of this income container here, and all of the expenses are in this expense container. So we cannot attach the event handler to these because then we would need two, but we only want one of them. So we find the element that is common to all of them, and that's again this one here. So with the class of container. So this is where we're going to put our event handler. Okay. So we say document.querySelector to select that element. And now we need to add this element to our DOM-strings object up here, right? So as we always did. And I'm just going to call it container here as well. Okay, and so the class container. All right, so let's go back. So what we want is DOM, because remember in here, in this function, it's not called DOM-strings, but DOM, which is this variable here, where we get this DOM-strings object from the UI controller, right? So DOM.container, and this is where we add our event listener. And it will be on the click event. And the function that we want to call, I'm going to call it control delete item. So control delete item. Okay, so it's a name similar to control add item. So this one will be control delete item. And so now we need to create this function, which is going to be called each time someone clicks somewhere on this container. Okay, so let's do it down here, actually after this control add item. So var control delete item. So a function, and here we go. And actually we need to pass something into this function, which is the event. And I'm sure that you remember what the event object is. So let's check out the other event handler. So in this event handler here, we also use the event object. So remember that the callback function of the add event listener method has always access to this event object. And we can call it whatever we want. We just call it event so that we always know what it is. And so it works here in this anonymous function that we wrote here in this case, but it also works if we pass another function in it. So in this case, control delete item. And then we can also say that we want access to the event object simply by putting this parameter in here. And the reason why we need this event here is because we want to know what the target element is. So remember, that's what we talked about before. So in event delegation, an event bubbles up and then we can know where it came from, so where it was first fired, by looking at the target property of the event. So let's simply start by console logging this property, okay? So console.log event.target. Alright, so let's now test this. Just reloading this file. Then let's hit somewhere here. So now the target of this click was this H2 element here, which actually even gets highlighted here. So if I now click somewhere here, let's say, then this one is the target element. So the element where the event was fired. So in this case where I clicked. If I click here, it's the container. So this element here. Now let me add something here. Say project. Okay, so if I now click here on this button, let's see what we get. All right, so we clicked here on this I element, so this icon, and what this means now is that each time that we hit this button here, actually we don't hit the button, but we hit the icon, okay? So let's get back at our HTML and take a look at this I element. Okay, so this one here. So when we click on the button, we actually click on this I element. Now, when we hit the button, it is not just the button that we want to delete, right? So we actually want to delete all of this here, right? Because all of this is the item on the user interface. And each of this item is identified by their unique ID name, which is this one here. So actually we are not interested just in this element here, which is the target one, but we're actually interested in this element here. So in this parent element. So again, this element here that we click is not actually the one that we're interested in, but it's this parent element. So this entire div element that we're actually interested in and that we want to have access to. So we need to move up in the DOM from here, and that is something called DOM traversing. So we're going to traverse the DOM. So let's see how we can do that. So back in our app file, we can now say that we want the parent node of this target. So this target property here, what it returns is an HTML node in the DOM. So when we want to move up from that, we can simply say parent node. Okay, so let's see what happens if we now hit the button. So reload, and now I need to add it again and just something random here. Okay, and now I'm hitting it, and now we see button. So it's no longer the I element, but the button. So let's go back. And what this means is that we actually moved up to the parent element, right? So let's make this more visible. Okay. So you see, the button element here is the parent element of the I, right? Now we don't want to just move up to the button, but in fact we want to move up all the way to the income. So we don't need one parent node, but we need 2, 3, and 4. So if we want to move all the way up here, we need to use the parent node property 4 times. And we can actually do that. So like this. Parent node dot parent node dot parent node. So this actually looks a bit strange, but it's gonna work. I hope so, at least. So test something, and now I'm hitting the button again, and here we are. So this is now the div element that we're actually interested in. And in fact, what we're interested in is the ID here, because again, this is the unique identifier, let's say, of this item. So we can simply use the ID property here. So that's it. With this, we have the ID. So just to prove it to you, here it is. So income 0. If we put another one, then it's gonna be income 1, okay? So each one has this unique ID, and this is gonna be very important, and we're gonna talk about that in a second. So now instead of logging it, let's save it to a variable called item ID, okay? Let's remove this one here, and then also declare it as a variable. So item ID. Now this is probably not the cleanest solution here, using all of these parent nodes, because with this we are heavily relying on the DOM structure, right? So basically we hard-coded the DOM structure here, but let's just leave it like this, because we in fact also hard-coded the HTML in here, right? So the HTML that generates all of these items. So it's not a big deal, it's not a big problem. if we also hardcode the traversing of that very DOM structure here as well. Now what happens if we click somewhere else on the page? For example, if we click here, then there is no ID, right? Or here, or whatever. Anywhere we click, there's no ID. And that's because there are no other IDs in the whole HTML document. And so we can now use this fact to say that we only want stuff to happen later if the ID is actually defined, okay? So now we can say if item ID, then we want something to happen, okay? And we already did this before, but again, this will work basically because this is going to be coerced or converted to true if this exists. And if it doesn't, then it will be coerced to false. All right. Now, what are we actually going to do with that ID? So again, let's take a look at how it is. So it basically contains both the type, so income or expense, and the unique ID of this item in our data structure, right? So 0, 1, and so on and so forth. And that is because this is exactly the way that we coded it. So let's see it back here. So in this method here, where we actually add the list items, we retrieve the ID from the new object, right? And then print it to our web page. So in case of an income, it's income and then the ID. And if it's an expense, it's expense ID. And actually let me change it here from income to inc and here to exp, so that we have always the same type designation throughout our app and not sometimes inc and sometimes income, right? So that wouldn't be so consistent, and this way it's much better. So right now, this ID here encodes both the item type and the item ID, right? So this will be extremely useful because later we can then use this data to tell the budget controller which item it should delete when we hit the button, and also which item should be deleted from the user interface. So let's use this ID here, okay? So back here, we now use this ID. Now the format of the ID, as we saw, is something like inc1 or whatever number. So we now need a way to split this up. And thankfully, there is a very handy method in JavaScript that all strings have access to, and that's called split. Now, you may be wondering why I said that all the strings have access to this method. Because we always said that a string is a primitive and not an object, right? Now, the thing is that as soon as we call one of these methods on a string, then JavaScript automatically puts a wrapper around the string and converts it from a primitive to an object. And then this object has access to a lot of string methods. And the same thing actually happens to numbers. So numbers also have methods because JavaScript simply transforms them from a primitive to an object so that we can use methods on them. So we will now use the split method. So let's say split ID should be the item ID dot split. So it's a usual method. And then we say that the split string should be the dash. Okay. And I will show you this in a second. Let me just declare it here. So split ID. Okay. So let's actually test this out in the console to see what the result will be. So imagine that we use this string var s is inc1, and then we say s dot split like we did before. And so what this returns is an array wherein the first element is inc, so this part that comes before or split string here, and then the second element is what comes after that. Okay? And s could even be bigger than that. So imagine it would be inc1 type 3, whatever, it doesn't really matter, just to show it to you. And then it would return an array of all of these elements that come after and before these split strings. So basically this allows us to break up a string into different parts and removing then the split string. So now we can simply say that the type is split ID 0, right? Because remember, this is the array that we just saw, and the first element is the type, right? Because it's this inc. So income or expense are the types. And I also need to declare this, of course. So type, and then we're also going to have ID. So that's the next one. So ID is the split ID and element number 1. So the second element, in fact. All right, and now we have all the ingredients to be able to delete the item from both the user interface and our data model, so the budget controller. And so let's look what we had on our to-do list for this part of the application. So first, we wanted to delete the item from the data structure. Then we delete the item from the user interface, and then we update and show the new totals. Or the new budget, actually, because that's the way we've been calling it, right? Because of course, as soon as we remove an item from the expense or from the incomes, then all of the budget has to be updated. So in the next lectures, we're going to create a function in the budget controller for this one. So for deleting from the data structure, and then a method for deleting the item from the user interface. And then finally, we want to update and show the new budget. So just to recap what we did in this lecture, we first set an event listener here to the container, which is the first element that all of the income and expense items have in common. So this is where we set our event listener. And we did it so because we want to do event delegation, which means that instead of adding one event listener to all of the elements that we're interested in, like all the incomes and all the expense items, we add them to the container and then let the event bubbling up. So the function that we then attach to the container is to control delete item, which is this one here, okay? And then from here we read the target element, okay? So using the event.target property, which is exactly the element where the click happened, so where the event was fired. And we then moved up in the DOM, so we traversed the DOM all the way up to the element that we're actually interested in. And then in here we retrieved the ID from it and stored it here in this variable. And this variable is going to be very useful for us because we know that in here is encoded the item type, so if it's an expense or an income, and also the unique ID. So we then isolated each of these into a different variable using the split method for the string. And so now the stage is set so that we can delete the item from the data structure and from the user interface over the next lectures. Let's now create a new method in our budget controller so that we can delete an item from our data structure. And so in this lecture, you're going to learn yet another method to loop over an array, which is called map, and you'll learn how to remove elements from an array using the splice method. So let's do that. So here's our budget controller in which we will add yet another public method. So let's actually put it here after the add item. We will have the method to delete an item. So delete item, a function, and so this is our method. Now we know that this method is going to be called by the budget controller, right? So what kind of information do we need to have in order to be able to delete an item from the data structure? So what parameters, what arguments does the app controller have to pass into this method? So let's look at our data structure. So here it is. And we know that in these arrays, we will have all of our expense objects and all of our income objects. Okay? And both expense and income objects, they are both identified by their unique ID, right? So what we need in order to delete one of the items from these arrays is we first need to know if we're talking about an expense or an income, and then we also need the unique ID. So this is what the controller will have to pass into this function. And so we need to set up the parameters here. So the type, which is the way we've been calling it, and ID. All right. Now imagine that we pass an ID of, let's say, 3 into this function. So 3. We cannot simply select the element that we want to delete like this. So data.allItems type, and then just use the ID here, right? So we cannot do it like this. So this would select our array here, right? So for example, the expense array, and then select the element number 3 using this, right? Now this would work if we were certain that the IDs are all in order like 0, 1, 2, 3, 4, 5, but we know that it's not the case. And we already talked about that when we wrote this method here, right? So we had this example here. So imagine these are the IDs. And so let's actually copy this example. So imagine these were the IDs. If you would then select the element number 3, so 0, 1, 2, 3, and would then delete it, you would not delete the element with the ID of 3, but with the ID of 6, right? So this is not what we want. And again, the reason for the fact that these are not all in order like 1, 2, 3, 4, 5, and so on and so forth, is the fact that we can delete items. And so in this case, for example, the elements with the ID 0 and 3 and 5 and 7 were all deleted, and that's why they're not here anymore in this example. And so we need to take that into account when we write this method. So what can we do now? The solution here is to create an array with all of the ID numbers that we have, and then find out what the index of our input ID is. So basically the index of the element that we want to remove. So let's say that the ID that we want to remove is 6, for example, right? Then the index is not simply 6, as we already discussed, but instead it's 0, 1, 2, 3. So the index in this case would be 3. So we need a way to find out why it's 3, so why it's the number 3 that we need to delete. So again, the solution is to create an array with all the ID numbers that we have. So let's comment this part out as well, because none of that is what we're going to do. Instead, what we're going to do is to loop over all of the elements in an incomes or an expenses array. So data.allItems and then the type that we pass in. And now let's meet a new method here. So before we used the for each method, right? But there is another one which is very similar called map. Okay? And map also receives a function, a callback function, which also has access to the current element, the current index, and the entire array. Okay? But the difference between map and for each is that map actually returns a brand new array. So in here, so in this function, in this callback function that is called for each element, we will always return something, and this will then be stored in a new array. So let's say return 2 simply. If we now say var IDs, then we would end up with a brand new array with the same length as the all items type array, but with the number 2 in all of the elements. So this of course wouldn't be so useful, because what we want is not a 2 in all of them, but what we want is the current ID. Okay? So going back to our example before, imagine that in the all items type we had 5 income objects which had these IDs, so 1, 2, 4, 6 and 8. So after executing this map method, we would end up with exactly this array. Okay? So let's actually call it IDs. Okay, so that we keep this as an example. And now all we need to do is to find that index. And we already know how to do that, right? So we say index is IDs dot index of the ID that we pass into the method. And it's really as simple as that. So let's now declare these, so IDs and index. All right. So remember, this index of method returns the index number of the element of the array that we input here. So again, imagine that the ID would be 6, then the index would be 0, 1, 2, 3, because this is the 6 that we're searching. And so this index variable here would become 3. So index equals 3. And now all we need to do is to actually delete this item from the array, right? Okay. And remember that this index here can be -1 in case that this item here is not found in the array in which we're searching. So we only want to remove something if the index actually exists, right? So if the index is different from -1, because -1 is when it didn't find the element. So if the index is different from -1, then we want to delete. And now, in order to delete, we're going to meet yet another method of the array. And this one is called splice. So don't confuse it with the slice method that we used before. This one is called splice. And this one is used to remove elements, while the slice elements is only used to create a copy. And so let's see how to use that. So data.allItems type, and this is the array of our objects, right? So on this array, we now can use the splice method. And it works like this. So the first argument is the position number at which we want to start deleting. And this is of course the index. And then the second argument is the number of elements that we want to delete. And we of course only want to delete 1. So again, this will start removing elements at the number index, which, if we come back to our example, is number 3. So at number 3, it will remove exactly 1. So in our case, it would be 0, 1, 2, 3, and then this one would get removed, like this, okay? Okay, so I hope that this small example here actually helped you understand why we needed to do it this way instead of just writing out this piece of code here. Instead, we had to create this entire array here and then retrieve the index of the element that we want to remove. So this one was a bit tricky, but we still solved it, right? And you also learned yet another 2 methods for arrays by writing this method. So I hope that you somewhere keep track of all these methods that we have already used on arrays, so that you don't lose sight of all the amazing things that we can do with arrays. And now the last step is to just use this method in the controller. So where is our method for that, or function actually for that? It's here. So the control delete item function. And so we say budget controller delete item. And now is the time where we can finally use this type and this ID that we created in the last lecture. Remember that? So we can now simply pass in the type, which is what our method expects, and the ID as well. And like this, the element with the specified ID and the specified type will be deleted from our data structure. So let's now see this in action, okay? So reload. All right, so we have a bug here somewhere. So in line 82, let's check that out. Line 82 all the way up here. Okay, we have 1 equal too much. Okay, so the equal operator is with 3 equals, and the difference operator is with this exclamation mark and the 2 equal signs. Okay, so again, and now the application has started. So let's add something to here. Let's say test 1, $10. Test 2, let's say 20. And test 3, 30. Alright. Now remember, if we click here to delete this, nothing will happen on the user interface. So we actually need to see our data structure, and we have our nice handy testing method here for that, right? So here's the object that we created with all the items, which are these 3 incomes. So 3 income objects with 10, 20, and $30. So let's now remove the second one. Alright, and we have a bug, so yet another one. So let's go to line 282. And 282 is down here. Okay, so this was a stupid mistake. It's of course ID with the capital letters and not like it was before. So I hope now it's gonna work. So test 1, test 2, and test 3. And now let's delete this. Alright, so I clicked the button, and again it wasn't removed from here, but let's take a look at our data structure. So our testing method, and now if we look at here, oh, we still have 3. So there's clearly still something wrong here. And since there's nothing happening here, so nothing happens when we hit these buttons here, so there's not even a bug, nothing happens really. So I suspect that there's something wrong with the if statement that we have. So let's go back. So this if here, remember that this gets only executed when the ID that we pass into is actually in the array. So when it's not -1 here, okay? And since this here is simply not executing, it means that probably this here always returns -1, and therefore this here is always false. So there must be some problem in here. And so let's check the ID. Maybe there's something wrong with the ID. So let's go down here. And so yeah, here's where we define the ID. So let's see how we did that. So we split this string here in 2, and then this created a new array, which is split ID, which had the 2 strings in it. So the type string, which is the first element of the array, and the ID string, which is the second element of the array. So the one with the index number 1. And maybe now you're starting to see the problem, and the problem is this. So we pass this ID into our delete item method, but remember that this is a string because it came from this item ID string. And therefore, up there in our delete item method, we are comparing a string to a number. So that's something that we cannot do. I mean, we can, but it's not going to give us the results that we want. So if we ask that the string 1 is in an array of 0, 1, and 2, which are all numbers, then the string 1 is not in there because what's in there is the number 1, okay? So we want this ID, this one here, to be a number so that we can then ask if the number is in the array with the index of method. So remember, we used the parse float function before, which was to convert a string to a float number, so a number with decimals. Now these IDs are integers, right? So no decimals. And so there's another function which is simply called parse int. So we're going to use that one here. So parse int. And just like this, we convert the string here to an integer, so to a number, which is then stored in ID. And so let's now check out if this works, okay? So reload, and then test 1, 10, test 2, 20, and test 3, 30. And in here are our 3 income objects. And now I'm going to delete this one. So again, we have no bug. So let's see our structure now. And yes, so now it's working. Now we have only 2 elements in our array. So great. So let's see the first one. It's test1. And the second one should be test3. Sorry. So test3, yeah. Because I deleted test2. Remember, I clicked here and I deleted it. So now it's finally working. And what we need to do next is to actually also delete the item here from the user interface, right? And then update the budget here, because this still stays the same. So I can delete all of this and nothing happens in the budget, right? So let's just check our data structure now that I deleted all of them. And so yeah, so we no longer have any income here because I deleted all of them. Okay, so this really works. And now we're ready for the next lecture. This is the last lecture about removing an element from our application, and all we have left to do is to actually remove the item from the user interface. And so in this lecture, you're going to learn some more DOM manipulation, and more specifically, how to remove an element from the DOM. And so in order to remove something from the user interface, we create a brand new method here in our UI controller. So here we have addListItem, and so after that, I'm going to put deleteListItem. So a function, once again. And what do we need to know in order to be able to remove an element from the DOM? That's right. We need a class name or an ID name so that we can first select it and then remove it. And in this case, of course, we're going to use an ID because we've been talking about that all the time. So let's say selector ID, right? And the ID that we're going to pass into this will be, of course, this entire ID here. So the one that we read from the DOM in the first place. So we don't want just the type or the ID, but we want the entire ID that we read. So for example, the income 0 or the income 1, right? So that we can then go ahead and delete this item, right? So for example, this item or this item, this is what we want to delete. And so let's do that in our method. And removing something from the DOM is actually pretty simple, because for that, we have the removeChild method. Okay, and since it's the removeChild method, we first need to know the parent, right? So basically, we have to move up in the DOM so that we can then remove the child. So this is a bit strange, but in JavaScript, we cannot simply delete an element. We can only delete a child, so remove a child. So we start by selecting the element, as always. So document dot. And now since we have an ID here, I will use getElementById. We haven't used that in a long time, right? So getElementById and then selector ID. So this is our item that we want to remove. But remember, we can only remove a child. So we first need to move up, and we already did that before, and we do that using the parent node property. So parent node, and now we can say, from here, we want to remove a child. And then we need to again select it. So really, this is a bit strange, as I was saying, but it's just how it works. So we need to pass this into here again. So this is how it works. Now I would suggest to not do it this way, but to first actually save the selection here in a separate variable, right? So let's say element is this, okay? And so then we say element, then we want the parent node from that element, and then we remove the child, which is this element. So pretty weird, but yeah, that's how it works. There's actually an excellent reference that I found where lots of these things are explained. So lots of DOM manipulations like this. So let's take a look at that. I already have it here. And you can also find it on my resource page, as always. And here we have a comparison between jQuery and the JavaScript DOM API. So this is for, let's see, removing elements here. So this is what we did here, right? So we selected an element, then set parent node and remove child and the element again, right? But here is a lot of different stuff that we can do, and some of that we already did. For example, let's see, so creating and inserting elements before and after is what we did here. So insert adjacent HTML, and we already used, I don't know if it was the after and, but it was something like this, okay? And so in here, you can find something for your needs if you want to do some DOM manipulation, like inserting or removing elements from the DOM. Okay, so our delete list item method is actually complete with this. So this is a pretty simple one, because all we really wanted to do here is to just remove this element. So let's now call it. So in here, so UI controller dot delete list item. All right, and now remember, we have to pass in the ID, and it's the item ID as we were talking about right in the beginning. All right, and now all we have left to do is to update and show the new budget. But that's really simple, right? Because we already have this code. So let's go here to our control add item function, so this one. So when we coded this part of the application, we already had this function here, which does exactly what we want. So let's just copy this and paste it here. All right. And that's why back then I said that we should create a function to update the budget, because we were going to use it again, and now is that time. So instead of writing the same code here in this function and in this function, we created an update budget function which contains all of the stuff that we do here. So let's remember what this is. So we calculate the budget, then we get the budget, so we basically read it from the budget controller, and then we display it on the user interface with the UI controller. Okay, so let's check this out. So I'm refreshing it, and then let's say salary 1500 or something like this, okay? And sold car 2000. And let's remove it. And it's gone. So it's working. So really cool. And did you see that also this budget here was updated? So not only was the element actually removed, but also the budget was updated. So let's remove this one as well. And so we're back to 0. So let's add an expense. Holiday 500. And now another income, like logo design for $2,500. So a great logo probably, right? And our salary again. So all of this has updated, of course. And now I'm removing this one. And yeah, again, it updated. It updated here. And so everything works perfectly. Let's only just look at our budget again and check if this is also empty. And yeah, it is. So perfect. And with this, we concluded the part 2 of the project, which was just to delete an item here from our application. And we did that perfectly. So our app is growing and growing and is getting better and better. So let's now move on to see what's next. Welcome back. Now that we have 2 out of 3 steps completed, let's look at what we have achieved so far. So this is the updated version of our app's structure. And now we also have the new functions and methods for deleting an item here that we just coded. So this is an overview of everything that happens when the user clicks one of the delete buttons. And this makes it visible why it was so important to create the update budget function, because it's used to update and display the budget changes after both adding and deleting an item. So let's move on to planning the rest of our app. So this is going to be the last step in coding our application. And so what is there left to do? The first thing that comes to my mind is these percentages here that show how much each expense represents in percentage of the total income. So that's the main thing that we're going to take care of now. So we calculate the percentages and of course update them in the user interface. Another thing that we have left to do is to display the correct month and year at the top of our app, because currently we only have some placeholder there. And there are actually a couple more things that we can do to improve our app, like getting this nice number formatting that we see all over the place here, and improve the user experience of the input fields in order to make it more clear if we're inputting an income or an expense. Alright, so yet another to-do list for us to work on here. And after doing all of this, we're going to be finished with our application. So are you as excited as I am to continue with this right now? Then join me right in the next lecture.